Hello, hi, namaskar everyone. Give me a quick response. Am I clearly visible and audible? Can you all hear me? Can you all see me? Shall we get started, everyone? Here we are again with this super one shot of relations and functions for class 11th. So if you are preparing for your boards in class 11th currently right now, and if you wish to revise the chapter relations and functions with this one session, here we are. Yes, so I welcome you all to this super one shot again, where we'll be discussing this entire chapter, relations and functions for class 11th with this one single video. Yes, you heard me right. So without any delay, let's get started. Thank you so much, everyone. Good evening, good evening. And with this, let's straight away get started. Shall we? So relations and functions, super one shot. I am welcoming you all for all the students of class 11th. We'll be covering it from scratch and we'll cover it totally. And do remember, if I ever conduct a poll in this session today, if I ever throw a question at you in this session today, and if you are supposed to, if you want to answer a particular question, you can answer it by participating in the poll. Sir, how are we going to participate in the poll? So to participate in the poll, the idea is really simple, students. You can participate in the poll with the PyLens application. So what is PyLens actually? PyLens is an application which you can download from either Google Play Store or from Chrome Store. If you're watching it on phone, you can download it from Google Play Store, or if you're watching it on your desktop or laptop, you can download it from Chrome Play Store. Then, sir, what happens? Then you can participate in the polls which we are conducting during this live. Not just that, let's say you're watching any random video on YouTube. You want to generate PYQs on that video on that topic. You want to get a mind map on it. You want to conduct a quiz on it. You want short notes on it and a lot of things. On any random video which you're watching on YouTube, you can generate by using PyLens. Got my point, everyone? And I hope you do remember this entire session, relations and functions, which we are conducting today. Yes. Okay, great, excellent. In that case, it is going to be amazing in that case if it is there for you. As for your weekly test, I think it is the right opportunity in that case, because today we'll understand all sorts of definitions and everything in a very clear manner regarding relations and functions. Everything, all the hacks, techniques, formulae, and approaches, everything for your weekly test and for your exam. Yes, we'll cover it totally with this one shot. So don't miss it, everybody. And I hope you do remember that all of these notes, this entire chapter's PDF notes, which we'll be covering today, can be availed by you if you visit our website pw.live. There will find our free course for 11th class, and there you can download it. I think the class will go on for around 2 to 3 hours, and definitely you can cover it totally with this, the entire chapter. Yes, Mayank, that's a good thing in that case. If you're covering it for your quarterly examination, for your regular yearly examination, or even for a unit test, this is going to help you totally and absolutely. Shall we get started, everyone? If you talk about the previous lecture, I hope you do remember, we did conduct or discuss sets. So sets as a chapter we have covered. Technically, sets, relations, and functions are one unit, but we have bifurcated it into two parts. So sets we have covered in the last session, and today we are covering relations and functions with this one shot. So without any delay, shall we get started? Sir, what all will be covering today? So if you ask me what all will be covering today, we'll talk about relations. Relations, not in general about the term relations. I'm not an expert on that, but relations in mathematics, I can teach you confidently. Then gradually from relations, we'll move towards functions, and we'll talk about different types of functions. And then when we talk about different sorts of functions, we'll talk about a lot of things which are related to functions like domain, range, and a lot of things we'll be exploring in today's session. So yes, everything which is there in your syllabus, everything which is asked in examination, everything which you need to know from this chapter will get covered with this session, with this one shot. As I've already mentioned, this class will last for another 2 to 3 hours. And with that, we'll be covering it or completing it totally. Before we get started, I hope you do remember what is a set. So let's say there is a set A and there is a set B. So there is a set A and there is a set B. So there are two sets, set A and set B. Imagine there is a set A which has, let's say, 3 elements. Set A has 3 elements which are 1, 2, and 3. So there is one more set, set B, which has 2 elements, let's say A and B. This is how you define, let's say, two sets. Now, when I say Cartesian product of two sets. Can somebody tell me in the comments what is the meaning of Cartesian product and how will you write the Cartesian product of A and B? Can somebody tell me in the comments? I'll be really glad and happy if you could assist me with a lot of things today. Definitely it is very useful for NDA. It is very useful JEE. It is very useful for any exam which asks 11th or 12th standard mathematics. But if you are specifically targeting IIT JEE, then we have a dedicated channel, JEE PW English. PWJ English. There you can specifically prepare for IT JEE in English. So there we come back with our discussion where we are talking about Cartesian product of two sets. So Cartesian product of A and B would mean A cross B. So this is how you write Cartesian product of A and B. Sir, what does it really mean? Cartesian product of A and B has ordered pairs. Sir, what kind of ordered pairs? Ordered pairs like 1, A. So first ordered pair will be 1, A. Then I'll have 1, B. Then second ordered pair will be 1, B. Then third ordered pair will be 2, A. Fourth ordered pair will be 2, B. Fifth ordered pair will be 3, A. And the sixth ordered pair will be 3, B. Everybody got it. Everybody understood it. Were you all able to process this? That's brilliant, Joy Rupesh. That's excellent. You know Cartesian product. That's brilliant. And with this, I'm sure everybody must have understood what do we mean by Cartesian product. So simply, I am mapping the elements of A with the elements of B. You can definitely score well in MP board or in whichever board you are. If you're preparing for boards in English, here we are to assist you at every single stage. This is the session and this is the entire batch for you. So in this batch, we are not only conducting classes for mathematics only, we are conducting classes for physics, chemistry, biology, English, and all of these classes, all of these one shots are brought for you at absolutely no cost, at absolutely free of cost. And that too comes with these handwritten notes and doubt clarification. Yes, you heard me right. This is a free batch. You can join this batch. You can enroll for this free batch by logging on our website pw.live. If you don't know how the total path or the complete path or the absolute path, you can check the link of this course given in the description as well. Shall I move ahead from here, all the participants? Here we are. I hope everybody is realizing when I say that A cross B I wish to write, then I am mapping the elements of A with B. What does it mean? It means, let's say I wish to write B cross A. Let's say I wish to write B cross A. So in that case, what would happen, sir? I hope everybody has realized it very clearly that, sir, if A cross B is something, then B cross A could be something different. Indeed, it would be. Let's say if I wish to write B cross A, I hope you all would agree with me that A cross B and B cross A are not necessarily going to be same. Yes or no, everybody? So when I talk about B cross A, sir, B cross A would mean A, 1. So element of B will be mapped with A. So B cross A will have ordered pairs as A, 1. It will have A, 2. It will have A, 3. Yes or no? Everybody got my point? Then, sir, you will have elements B, 1. Then you will have B, 2. And the last ordered pair will be B, 3. How many of you understood it completely? How many of you have gotten it totally? Did you all get it? Did you all understand it? Everybody with me so far? Yes or no? Definitely. We'll definitely forward this request to the defense wala that they should bring sessions in full-fledged English and pure English as well, so that you can attend those classes in pure English as well. We'll definitely forward this request. But right now, shall we come back to this discussion, everyone? Are you all getting it? How did I explain A cross B? How did I explain B cross A? Did you all understand both of the things, all the participants? Shall I move ahead from here? That's great. If you have gotten it, can somebody now help me with the number of elements in A cross B and the number of elements in B cross A? If you could write the formula in the comments, I'll be really happy. Can somebody tell me what should be A cross B or B cross A, the number of elements I'm asking now? That's good, Vijay. That's good, Vijay. Brilliant. Keep it up. So I hope everybody is very clearly realizing when I wish to talk about number of elements in A cross B. So cardinal number of the set A cross B, can it not be equal to number of elements in A into number of elements B? Because all of these three elements are mapped with these two elements. Vijay, this is the second class technically. The first class on sets we have already conducted in the previous one shot. So this is an extension of that unit, relations and functions we are doing today. So number of elements A into number of elements in B will give me A cross B number of elements. So number of elements in A are 3, number of elements in B are 2. So number of elements in A cross B are going to be 6. The same thing I hope you're realizing would have happened here as well. If I'm asked to figure out number of elements in B cross A, it would have been number of elements in B into number of elements in A, which is again 2 into 3. That's again nothing but 6. Excellent. Keep it up, students. That's brilliant. That's brilliant. So I hope first of all, you're able to understand the meaning of the term Cartesian product. Yes or no? Yes or no? Did you all get it? Everybody got it. Now let's say there is this Cartesian product A cross B. There is this Cartesian product A cross B. And from this Cartesian product A cross B, I am taking certain elements. Which means, let's say I'm choosing some elements. For example, I have chosen 2 comma A, 2 comma B, and 3 comma A. These 3 elements I have chosen. Definitely, Vijay, we'll continue this series until your JEE examinations. If you're worried about 11th class chapters, we'll cover it not only here, but we'll be covering it on our channel PWJ English as well. So right now on our PWJ English channel, we are conducting one-shots of physics, chemistry, and maths of class 12th. And very soon we have planned to bring the class 11th one-shots as well on JEE English channel as well. That will be JEE specific. Here we are conducting board-specific one-shots. I hope you got my intent in point. So let's say I have chosen some ordered pairs from A cross B. What did I do? From A cross B, I have chosen some ordered pairs. So this was set A, this was set B. Set A had elements 1, 2, 3. Set B had elements A and B. But I have chosen, let's say, these 3 elements. So which 3 elements? Ordered pairs which I have chosen are 2 comma A. So 2 comma A I have chosen. Then I have chosen 2 comma B. And I have chosen one more element, which is 3 comma A. So these are the few pairs I have chosen. So what are we doing here is we are simply saying, my name is Deependra, by the way. Here we come that 1, 2, 3 are the elements in set A. A and B are the elements of set B. And if I take some elements of A, map those elements with B, mapping, I hope you understand. With ordered pairs also you can relate them. So if I map elements of A with the elements of set B, then this mapping is called a relation. Now, sir, do relations really follow any rule? In mathematics, they don't. In real life, they should. But in mathematics, they don't. Just like in real life. So what I'm saying here is that mapping of any of these elements with any of these elements in any possible manner is a relation. Sir, what are you saying is totally not understandable. Can you re-explain? Yes. What I'm saying is that 1, 2, 3 in all possible manner can be mapped with A comma B in these 6 ways. Out of these 6 ways, if I choose some ways or choose some possibilities, it will be called a relation. For example, this way I have chosen. So, sir, is this the only way I could choose it? Absolutely not. You could have chosen some other ordered pairs. You could have taken some other ordered pairs. And in that case, it would have been some other relation. So that's how I could have had a lot of different types of relations. Which means, let's say, if I don't choose this, rather what I choose is, let's say, something totally different. Something totally different means, let's say, here in this case, I am choosing elements like 1 comma A, 2 comma B, and let's say 3 comma A. These 3 elements I have chosen. So if I am choosing these 3 elements, in that case, what happens is, please pay attention everyone. Here you have set A, here you have set B, and from set A to set B, if I map elements which are 1, 2, 3 with AB, the mapping I'm choosing now is 1 with A. So 1 is mapped with A, 2 with B. So 2 is mapped with B. And the third mapping which I'm choosing is 3 with A. So 3 is mapped with A. So these are the mappings I'm choosing. So if these are the mappings which I've chosen, this is again called another relation. So let's say if the previous relation was noted as or titled as R1, relation 1, then this relation can be called R2. Are you understanding it? So how do we define a relation? Here, if I wish to define this relation R2, I'll be in a more proper manner, will be defining this relation R2 as, Please pay attention, everyone. I hope everyone is there. In R2, I'll be having 1 comma A, I'll be having 2 comma B, and I'll be having 3 comma A. So these three elements, I'll be having this relation R2. So instead of writing it as A cross B now, I'll say there is a relation R2. There is a relation R2. And this relation R2 is defined from set A to set B, from set A to set B, which has elements 1 comma A, 2 comma B, and 3 comma A. So what does it mean? It means its domain, this set A, whose elements are mapped with this element of set B. So this set A over here is called the domain. So this set A here is called the domain set. This set B is called the codomain set, but technically from R2, which elements are there in set A which have images here? So 1, 2, and 3 have images A and B. So 1, 2, and 3 have images A and B. So these elements 1, 2, and 3 are called the domain of R1. Sorry, the R2. So here if I'm asked the domain of R2, I'll be saying domain of R2 is 1, 2, and 3. Domain of this relation will be 1, 2, and 3. Everybody getting it? Sir, what about the range? If I talk about the range of a relation R2, if I talk about the range of a relation R2, then I'll be preferably defining it as all the elements in this set B which have pre-images. All the elements in set B which have pre-images, which means this element A has a pre-image 1 and 3. This element B has a pre-image 2. So all the elements which have pre-images are called the range. So range here is going to be small a and small b. I repeat, the concept is really simple. Let's say I give you a relation R3. I give you a relation R3 which has elements as, let's say 1 comma A, 1 comma B, 2 comma A, and let's say 3 comma A. So now this is how the mapping looks like, that 1 is mapped with A, 1 is mapped with B, 2 is mapped with A, 3 is mapped with A. Absolutely. That's a very good observation, Vijay. Now you help me with the domain of R3. So domain of this relation R3 would mean just pick these elements 1, 1, 2, 3. And I hope you do remember, in a set, we don't write an element repeatedly, which means if I'm supposed to write the domain of R3, I'll be saying its domain is 1, 2, and 3. Isn't it absolutely simple, direct, and clear and straightforward? What if I ask you the range of R3? Can you help me with range of R3, everyone? What is going to be the range of R3 here? Can somebody help me with the range? So range would simply mean these elements, A, B, A, A. So I think there are two elements only, A and B, and that's your range. Did you understand it now, Dr. Akash, or shall I re-explain this? All the participants. I hope it's clear, direct, and straightforward. Everybody understood the concept of Cartesian product, ordered pairs, relation, domain, and range. 5 things I have covered so far. Any confusion on anything, please ask. If there is any confusion, doubt, or query, I'll explain. That's good, Mayank. That's brilliant. All the participants, everyone comfortable with this? I repeat, all what we have done so far is, I first of all told you, there is a set A, there is a set B. Cartesian product, we have taken A cross B. From this A cross B, this is technically a set A cross B, which is a Cartesian product of two sets, is again a set of ordered pairs. So this 1 comma A, 1 comma B, they are called ordered pairs. So from this set A cross B, if I take any subset, I repeat, from this set A cross B, from the Cartesian product of A and B, that is A cross B, if any subset is chosen, if any subset is chosen, then that subset, or I'll say that set, that subset or that set is called a relation, is called a relation from A to B. Did you all understand the definition of a relation, first of all the participants? What did I do or what did I say? I said that I took A cross B. So A cross B was what? 1 comma A, 1 comma B. It was 2 comma A, 2 comma B. It was 3 comma A and 3 comma B. Yes or no? Then from this relation, if I choose any subset, so these ordered pairs are its elements. So there are 6 elements. So if I choose any subset, let's say, sir, in this case, I am choosing a subset, this one, 1 comma B, 2 comma A, 2 comma B, 3, these 3 elements I have chosen. So if I have chosen a subset, let's call it a relation, and this time I'm defining it as R4, which has elements 1 comma B, 2 comma A, and 2 comma B. So this is again a relation. Everybody understanding it? Excellent, excellent. Yes, indeed. So this is called a subset of Cartesian product of A cross B, which is a relation. So that means we can define a lot of relations. Yes, but it will still be a countable number. A lot means a countable number in this case. What does it mean? My cadets, sir, when will the one shot of chemistry will be released? Very soon, very soon. You will get all the subjects. You will get maths, physics, chemistry, biology, English. Even in biology, all the subjects you have, botany, geology, everything you'll get. Hello, hi, namaskar, everyone. Shall we come back to the discussion we all are having over here? Now, if I get back to the discussion where I'm asking you the total number of relations from A to B, what will be your answer in that case? What did I just ask you now? I am asking you the total number of relations from A to B. My question now is, what is the total number of relations from A to B? What would that be? Can somebody answer that question in the comments? I'll be really glad and happy if you could tell me. What could be the total number of relations from A to B? Can somebody help me? If you want to know the hint is in the last session. So if you don't get this part, you should or you need to watch the previous session which we conducted on sets. So can somebody help me with the formula? If set A has certain elements, set B has certain elements, what will be the total number of relations from A to B? What is N here, Vijay? What is N? Good observation, a very good observation. Mayank, you need to correct 6. Eros, my friend, what is image and what is pre-image? These elements 1, 1, 2, 2, 3, 3 have images A, B, A, B, A, B respectively. And if I ask these A and B, A, B, A, B, A, B about their pre-images, then these elements 1, 1, 2, 2, 3, 3 are the pre-images. Exactly, that's brilliant. That's brilliant. So I hope you all do remember that here if I'm asked about the number of subsets of A cross B. So A cross B is technically a set which has 6 elements. Now what is the relation? Sir, a relation means all the possible ways in which you can choose some elements out of A cross B. Those will be the different relations you can have. So, sir, if I have 6 elements available with me, what are the possible ways I can choose some elements? So, apply your brain, apply some logic. I'll say, with this element, I have 2 choices. And with this element, I have 2 choices. And with this element, I have 2 choices. And with this element, I have 2 choices. With this and this also, I have 2 choices. Sir, what do you mean by 2 choices? I will either take it or won't take it. I will either take it or would not take it. So with every single ordered pair, I have 2 choices. So in the chapter Permutation and Combinations, when we talk about the basic principle of counting, there I'll explain that if each of them have 2 choices, the total number of choices I now have are 2 to the power 6. What does it mean? It means 2 to the power number of elements in A cross B, which means 2 to the power number of elements in A into number of elements in B. It means, yes, absolutely. That's a very good observation, students. Keep it up. Here I'm saying that if I'm ever asked that how many relations can I define uniquely, distinctly, separately, totally, I'll be saying if set A has number of elements NA, if set B has number of elements NB, then the total number of relations from A to B will be 2 to the power NA into NB. Absolutely, absolutely, Vijay. And in this case, 2 to the power 6 means 64. So here, 64 unique, distinct relations will exist from A to B. Everybody got everything, whatever I've said so far on this slide. All what I've said so far is Cartesian product, sets and their Cartesian products. And then we did discuss about ordered pairs. Then we talked about fetching some elements from that Cartesian product. We defined it as a relation. And when we were talking about a relation, we talked about domain and range. And domain and range came with the concept of image and pre-image. So I hope this part where we are reaching here right now at this stage, where we are talking about the number of relations from A to B, which is 2 to the power NA into NB, have you all decently and completely and totally understood? Yes or no? Shall I move ahead from here, all the participants? Shall we talk further about few more things if you all have understood it comfortably? And by the way, if you want to receive this entire PDF, this entire one shot, then we will be providing it to you at absolutely free of cost with 24/7 doubt clearance, that too at no cost, with our free batch. The link to our free batch is given in the comments as well as in the description of this video. You can avail all of this at no cost. This entire series for physics, chemistry, maths, biology students we have brought for 11th and 12th both. We haven't introduced functions. How can I introduce functions, arrows before relations? Before understanding functions, you need to understand relations. So I think relations, how will I relate? I think it's like a vending machine. So what kind of vending machine? It's like a vending machine. I hope you do understand vending machine, but it's a malfunctioned vending machine. It is a corrupted vending machine, which means it is not functioning properly. It is not working properly. For example, here we have a vending machine which has few items like, let's say there is a Pepsi, there is a chips packet, there is some other thing as well, which is all junk, which you should not eat. So let's say this is item 1, this is item 2, this is item 3, this is item 4, this is item 5. So how should it technically behave? So there are buttons given to us, button number 1, button number 2, button number 3, button number 4, and button number 5. So when you press a button, it should give me that item out of this vending machine, yes or no? So if I'm pressing button 1, I should get item 1. If I'm pressing button 2, I should get item 2. But relation, as a concept is so chaotic in nature, that means, let's say relations are like this, that if I'm pressing 1, let's say, then I'm getting item 1 and item 2. Let's say I'm pressing 2, then I'm getting item 4 and item 5, item 3. When I'm pressing 3, let's say I'm getting all. So it is very badly knitted. It is very badly connected. I mean, anything can be connected with anything. Anything can be mapped with anything. You can have anything mapped with anything. So let's say this is the domain, this is the codomain. So here, this is your domain and this is the range. But here, anything is mapped with anything, which means, let's say 1 is mapped with I1, but 1 is mapped with I2 as well. So when I press the button 1, it gives me an output I1 as well as I2. So this is how a machine should not behave or function, right? So this is a corrupted machine. This is a malfunctioned machine. And that's how I will define relations in a layman language, in a very simple language. If I could explain it to somebody in 7th or 8th standard, this is how I'll take it. I'll give this kind of analogy. But if I were to explain functions here, I'll say a properly functioning vending machine would be a function, which means, let's say, if I have 1 as an input, it should give me 1 output. If I have 2 as an input, it should give me item 2 as an output. If I have 3 as an input, it should give me 1 unique output. So whatever button I press, it should give me 1 unique output. So if we are getting that, I'll be calling it a function specifically. It will still be a relation because in any possible manner, you map the elements of domain with the elements of range or codomain. There, you create a relation. But to be more specific, if I were to define functions, I'll say a properly functioning vending machine will be a function. Sir, we are still not getting it. Can you explain it mathematically? I mean, how are you going to write it in the examination? Are we going to give a vending machine example there? No, of course not. I am telling you this because I want you all to understand, first of all, mentally, are you able to process it? In your brain, are you able to imagine both of the scenarios? Are you able to differentiate a relation from a function? By the way, how many of you have already covered or studied this chapter in schools, the chapter relations and functions? And I hope with this session, you're getting more clarity in that case. Yes or no? So now, if somebody asks me that, sir, please define functions. I hope so far, relations everybody has understood comfortably. Sir, what do you mean by function then? How do you define function? So function is defined as a special case of a relation. So first of all, it is a special case of a relation. It is a special case or a type of a relation. This is a special type of a relation where all the elements in the domain or from the domain set have unique image. If that rule is followed by a relation, we would still call it a relation, but preferably I'll call it a function. Did you all get it, or shall I repeat this? Everybody. Sir, this looks good in terms of definition, but I think we'll be not writing it like this. Shall I, not understand it more properly? Yes, you should. Let me take some scenarios. Let me bring some cases for you, and then we'll talk about whether it is a function or not. So you help me. I'm giving you some scenarios, and you tell me whether it is a function or not. So this is the domain. This is codomain. It has elements 1, 2, 3, 4. It has elements A, B, and C. So 1 is mapped with A, 2 is mapped with B, 3 is mapped with C. As per this definition, what do you think? Is it a function? As per this definition, what do you think? Is it a function? As per this definition, what do you think? Is it a function? Let me just make some copies of it so that I can present different cases and ask you about a function being relation or a relation being function, to be more specific. So first case I'm giving, 1 is mapped with A, 2 is mapped with B, 3 is mapped with C. Will you call it a function? Do tell me in the comments. Is this mapping a function? Will you call it a function? Absolutely, Vijay. A very good observation. This is clearly not a function. Sir, why? This is not a function, Anamika. I hope you are noticing it. Why? Sir, because you told that a special type of a relation where all the elements in the domain should have a unique image. So, sir, you are saying that all the elements from the domain should have a unique image. Where is the image of 4? Where is the image of 4? 4 is there in the domain. Yes or no? A, B, C are there in the range. So, sir, 1 has image A, 2 has image B, 3 has image C. A has pre-image 1, B has pre-image 2, C has pre-image 3. But where is the image of 4? Exactly. So if it does not have an image, I'll not call it a function. Great. Perfect. That's good, students. Keep it up. That's good, Eros. That's good, Vijay. That's good. I hope you got it. That's brilliant. In that case, let me ask you one more question. Sir, 1 has an image A, 1 has an image B, 2 has an image B, 3 has an image B, 3 has an image C, 4 has an image C. So, sir, now it is a function, isn't it? Now this is a function, yes or no? Tell me in the comments. Is this a function according to you? What do you think? Will you call it a function? Here, this set is called the domain again. This set here is called the codomain set, which right now let's call range for a while. What do you think in this case now? Is it a function here? Sir, you said all the elements should have image. No, you didn't hear me right. You didn't hear me right. I said all the elements in the domain should have unique image. Must have a unique image. Brilliant, arrows. That's good. This is again not a function because I'm sure some of you may have noticed Sir, one has two images A and B. So one has two images A and B, and this is a clear violation of this condition of unique image. Yes or no? Everybody getting it? Absolutely, absolutely. Good, Anamika, good Eros, good Vijay. That's a brilliant observation. In that same manner, I'll say that 2 has one image, that's unique. But again, if you look at 3, 3 also has two images, which are B and C, which is again a violation of this concept of unique image. Although it got violated at 1 only, so I need not verify it further, I'll definitely say this is indeed a relation from A to B, but this is clearly not a function. So this is also not a function. Everybody getting it? The previous case is also not a function. Okay, so shall we talk about one more case? Here we have 1 is mapped with A, 2 is mapped with B, 3 is mapped with C, and 4 is mapped with B. Sir, I think this is also a violation because 2 and 4 have an image B. Is this really a violation, students? Tell me honestly, will you call it a function or it is merely a relation? What do you think? Is it a function or a relation? I mean, is it a relation only, not a function, but this is, what do you call? A relation as well as function? Can we call it a function here? Are we fulfilling all the conditions for this relation to be a function? Good Anamika, what do you think? Is it a relation or a function? Of course, anything here mapped with anything will be a relation. But what about it, a function? It is a function. Indeed, it is, Vijay. That's a very good observation because the condition is all the elements in the domain should have a unique image. So when I look at the different elements, sir, 1 has an image A, 4 has an image B, 3 has an image C, even 2 has an image B. So, sir, are you not noticing that 2 and 4 both have an image B? So how come it is a violation? It is clearly not a violation. Yes or no? It is indeed a function. Good errors. I hope you all are realizing that here 2 is mapped with B, 4 is mapped with B. So it is a many one kind of a mapping, but it is still a function. Because when I look at 2, I ask it, how many images do you have? It will say only one, that is 2. So unique image it has. If I ask 4, how many images do you have? It will say 1, that's B. Again a unique image. So first of all, are all the elements in the domain having unique images? Yes, yes, indeed. So if they have unique images, this is clearly a function. Of course, it's a relation, but being more specific, it is a function. Everybody got the idea of a function. Were you all able to process this idea of a function? Yes or no? Have you all gotten it? Have you all processed it? Have you all understood it? Now, there we do a test by which you can check whether a given graph is a function or not. So to check whether a given graph is a function or not, it is called vertical line test. It is a short trick which we usually tell students in JEE, although it is not even asked in JEE these days. But still, if you want to check whether a given graph is a function or not, so let's say here you have y-axis, here you have x-axis, and let's say this is the graph of a relation. This is how a relation is defined. This is x-axis, this is y-axis, and here you have a graph of a relation. And let's say I'm asked to figure out whether these graphs, which are representing relations, are functions or not. Can somebody tell me what do we do with vertical line test? Is anyone aware of this vertical line test? Can somebody in the comments tell me what do we really mean by the vertical line test? Anyone? Vertical line test here says that if you draw a line parallel to the y-axis, that means a vertical line. And if that line anywhere on this curve is able to intersect it at either once or not even once, but not more than once. I mean, if I'm drawing that line parallel to the y-axis and I'm noticing anywhere on the curve, it is not intersecting this curve more than once, then I will, without any hesitation, call it a function. It is a function. Yes or no? Absolutely, absolutely, absolutely. Yes, indeed. I repeat, If I draw a line parallel to the y-axis, and if I see that anywhere on the curve, if it intersects the curve at more than 1 points, anywhere on the curve, if it intersects the curve more than 1 points, anywhere on the curve, if I notice that it intersects the curve at more than 1 points, I'll be calling that this is not a function. Can somebody tell me why? Why are we really doing it? I hope some of you must have already noticed that, sir, if this is an input, which is, let's say, x, so here I am receiving an output which is y1 corresponding to x1. I am receiving another output which is y2 corresponding to x1. I am receiving another output which is y3 corresponding to x1. So here if I look at its mapping, x1 will be mapped with y1, it will be mapped with y2, and it will be mapped with y3. And sir, this is a crystal clear violation of a definition of a function where we told that an element in the domain should have a unique image in the codomain. So if an element in the domain does not have a unique image in the codomain, I hope you do realize, no, roots is a bad word here. I'll say if an element in the domain does not have a unique image, it has more than one images, then it is definitely not a function. It is merely a relation. My friend who's constantly asking me to explain in Hindi, my sincerest apologies with you. We are not supposed to speak in Hindi. This is PW English medium, where we teach in pure English, where we teach in full-fledged English. If you really wish to learn in Hindi, we have our channels, our very own channels, PW Hindi medium, PW English. There you can learn all these things in Hindi. So coming back to the discussion, everybody, are you getting it? This is clearly not a function because it has more than one images. But if I talk about this case, anywhere I see on the curve, all the elements in the domain have unique images, yes or no? But sir, are you not noticing that this y1 could be an image of x2 as well? Then what's the problem over here? Is it really a problem? Sir, x1 and x2 both have an image. They both have x1 and x2. They both have an image y1. So is it really a problem? Many to one is definitely not a concern for us. What is the concern? The concern is one to many should not be there. Errors, let's focus. Errors, let's focus. I repeat, whenever you are given a relation in one to many form, this cannot be a function. I hope so far you have been able to develop this. But if you are ever given something like many to one, this can definitely be a function. All I need to ensure is that every single element in the domain should have a unique image. It must have a unique image. Everybody got it? Everybody understood it? So far, are you all able to process the functions, the concept of functions? Yes or no? Now, here, let me just take some of the cases. So I hope so far you're able to process functions as a concept of machine. I think on the thumbnail of this video also, I have asked my YT SEO to put a machine like this. So he deliberately was asked to keep a machine like this, where you pass on some inputs, inputs are processed by an expression, by a function, and then it produces the outputs. So function is like a machine. Function is like a machine. Function behaves like a machine. It does behave like a machine. So what do you really mean by that? Let me try and tell you this thing here, over here. Please pay attention, everyone. Let's say if I define f of x, so f represents function, x means the independent variable, which follows a fixed definition, let's say x square. So here it means, or you could have written it as y is equals to x square as well. What does it mean? It means here this x is your independent variable. This x is your independent variable. And then this f of x or y is called dependent variable. Sir, why dependent and independent? Dependent variable you'll call it because whatever values x takes, based on those different values of x, y will be producing those values or outputs. So y is dependent on x. So x can independently take a lot of values and y will correspondingly take different values. I'll come to this concept of machine, but before I talk about the concept of machine, you help me. Whatever values of x I can put here, will be called the domain of this function. Whatever values of x I can put here, based on that, whatever values are produced as an output, which are the values of y, will be called the range of this function. I repeat, all what I'm saying is, whatever inputs you can give are called the domain. Whatever outputs we can produce based on those inputs will be called the range. If you're still not getting it, can somebody help me that what all inputs and what all outputs can we give here? Can somebody tell me in the comments what all inputs and outputs can we give here or get here? So let's say this is a function fx, which is equal to x square. Then what is happening over here? I hope you do notice that as an inputs, what all I can pass? Sir, I can pass a set of all the real numbers in the world. I can pass a set of all the real numbers in the world. All the real numbers in the world I can pass. I hope you're getting it. I can pass -1, I can pass 0, I can pass 1, I can pass 2, I can pass √3. I can pass any number. Will that be a problem? Of course not. Yes, Anamika, are you asking me to explain domain, range, and codomain, or are you explaining it? And based on those inputs, we'll be producing the outputs. Based on those inputs, we'll be producing the outputs. But can you help me with the range here, the outputs? So I hope some of you must have noticed, whatever real number you pass to it, when it is squared, it will be producing the output as a non-negative real number. Absolutely, Vijay, that's brilliant. I'm sure a lot of you must have been able to think that if this was the domain, which was all the real number, then I would have said the range is all the non-negative real numbers. So range is all the non-negative real numbers. And this concept of intervals, closed, open, all of that we have already learned in the chapter sets. Do you remember that? When we covered the chapter sets, we talked about a lot of things. Do you remember that? So if you're feeling confused with closed and open interval or something like that, you need to watch the chapter sets again. But I'm sure it is understandable. You're getting it totally, aren't you? So here, whatever inputs I process here, those inputs will become non-negative. -1 square will be 1, 1 square will be 1, 0 square will be 0, 2 square will be 4, √3 square will be 3, something like that. So I'll keep getting no errors. There is a difference between R plus and there is a difference between non-negative. Try and understand. There is a difference here. Let's say this is the number scale. So this is 0. These are all positive numbers on the right of 0. On the left of 0, these are all negative real numbers. So on the right of 0, these are positive numbers. On the left of 0, these are negative real numbers. So if I say that I am talking about non-negative real numbers, then what am I saying here is? Non-negative. Mind, let's focus, shouldn't we? Non-negative real numbers. So non-negative means negative I don't want. Sir, what is 0? 0 is that neutral number which is neither negative nor positive. 0 is neutral number, which means if I don't want a negative number, I want non-negative real numbers. So I'll say I want a 0 or positive number. So I'll say it is 0 to infinity. Did you get my point? What if I ask you the set of non-positive real numbers? What will be your response in that case? I hope everybody has gotten it. Non-positive. Sir, we don't want positive ones. So if I don't want positive, I want either negative or 0, which means the set of -infinity to 0, where 0 is included. Did you get it now, Eros? The difference between R plus and non-negative, there is a difference. And you got it, I hope now. Yes or no, everybody? Yes, positive means 0 to infinity, where 0 is open. Absolutely, Vijay. Good observation. These minute details matter a lot. When you prepare for exam like IIT JEE or something like that, they play with these words. They play with these kind of notions. Where they ask you to deal with this kind of language. They often play with this kind of data. Where people get confused. Where people feel confused. Shall I move ahead from here, all the participants, if you have gotten it? Now, can somebody tell me what is an identity function in the comments? I'll be really hoping and expecting an answer or response from your side. Somebody quickly tell me. What do you really understand by an identity function? Anyone? Anyone who's explaining the concept of identity functions over here? Nobody? Okay, I hope some of you may have studied this function y is equals to x, or you may call it fx is equal to x. Remember that exact same output as input. That's brilliant. You don't think, you are correct. Absolutely correct. So if I were to draw its graph, how will you draw its graph, students? This will be the, let's say, y-axis. Amazing. What has just happened? I think I was trying to draw a circle. Okay. So let's say this here is the y-axis and this here is the, let's say, x-axis. Yes or no? And if you are drawing a straight line, which is passing through the origin, and it is making an angle 45 degree with the positive direction of x-axis. Sir, why are you discussing all these details? Because you are going to study these anyways in the chapter coordinate geometry. Exactly. That's good, Vijay. That's brilliant, students. Keep it up. So here, whatever input I'm processing, that same output is getting I'm as processed, which means 1.1 if I give as an input, 1.1 I receive as an output. Root 3 if I give as an input, root 3 I'll receive as an output. 7 by 5 if I put as an input, 7 by 5 I'll get as an output. Getting my point, everyone? So if something like that is happening over here, it is called an identity function, y is equals to x. I am more interested in knowing the domain and range of this function. So can somebody quickly tell me what is the domain and range here? Anyone? What is the concept of domain, sir? It's a very simple idea where you just check the existence of the function along with the x-axis. So sir, I think on the x-axis, the graph exists from minus infinity to infinity for all the real numbers, doesn't it? I mean, I can process any input here. It's a polynomial function of degree 1. And polynomials can process any input. You pass them any value, they can process it. Which means what? I'll say, if you ever ask me the domain here of this function, what will you say? The domain of an identity function is set of real numbers. That is minus infinity to infinity. That's good, Vijay. I'm sure other students were also able to crack it. Yes or no? But sir, what about the range? Can somebody help me with the range as well? What do you crack range as here? I hope some of you must have noted it again, that along with the y-axis, whatever values are getting produced is going to be the range. And sir, I'm seeing the existence of the graph from minus infinity to plus infinity. Okay, Ashish, in that case, sincerest apologies. Don't worry, you will. Just keep trying. I'm also putting my best here. So range means what? Whatever values from minus infinity to infinity you could keep, all those values are range. Yes or no? Everybody with me. That's brilliant. That's good. Good errors, Vijay, everyone. That's brilliant. Shall I move ahead from here? If you got this point, if you were able to process this idea of concept of domain and range for this identity function. Excellent. With this, if I could try and tell you the next concept, which is called constant function. So constant function is denoted by f of x is equals to c, where c is a constant. For example, just to make you understand this, let's say I'm taking a function y as 5. This is a constant function. What does it mean? Let's say this is the y-axis. This is the x-axis. So here, if there is a straight line parallel to the x-axis passing through 5, 0, 5 technically, which I'll call a straight line parallel to the x-axis, I'll denote it by 5, y is equals to 5. Which means if I have inputs from minus infinity to infinity, which means on the x-axis, I can try any value from minus infinity to infinity, yes or no? Just give me a moment, students. Let me just get few unnecessary elements removed so that I can focus on my teaching, and then we'll continue. Just give me a moment. So these two people's comment I won't be able to see further, and I'll be able to continue with my utmost focus. Okay, coming back here. Minus infinity to infinity, these are all the numbers I can pass as inputs, yes or no? I indeed can. So this means, again, what would be the domain? The events in A are having same image in B. Events, elements, Vijay. So here I repeat, the domain, if I talk about the domain of a constant function, will again be all the real numbers, yes or no? Because sir, whatever input you want to pass, you can. But can you help me with the range here in this case? Anyone? What do you think would be the range here? Anyone? Sir, range here is not minus infinity to infinity. If you travel on the y-axis, you are getting only one element, which in this case is 5, or in the case of constant function is one single element, that's C. Everybody processed it. Everybody got it. Are you all there? So I hope everybody is clearly realizing that, sir, if you talk about the range, I'll say range is one single element, that in this case is specifically 5, but in this case, the range here will be defined as one single element, which is C. Absolutely, absolutely. Output is same regardless of input. Exactly, Raj. That's a very good observation. Very good. Everybody noticed it. Everybody got it. Comfortably, all the participants. Yes or no? One more thing you all must be able to understand is that input can be anything. Output is fixed. And if there is exactly and only one output, instead of using open or closed interval, I'll be using the concept of set theory, curly brackets, because exactly one element is there. Shall I move further from here? If you are able to understand the concept of constant function, shall we now talk about polynomial function? What is the meaning of a polynomial function here? Polynomials, do you understand? For example, if I ever explain a linear polynomial function, so I'll explain few polynomials for you, linear, quadratic, cubic and all. So let me begin with the linear one. So let's say if I'm given fx is equals to, let's say if I'm given fx is equals to 2x plus 3. I'm taking a generic case here. So 2x plus 3. Although we'll be covering it in coordinate geometry, but right now also I'd like to tell you that here we will have this case where fx is equals to 2x plus 3 is a polynomial of degree 1. And in 10th standard, you must have probably studied that y is equals to 2x plus 3 is clearly a straight line. So an equation in two variables, a linear equation in two variables where variables have power 1 is an equation of a straight line. Yes or no? Do you remember that? Exactly. Vijay is trying to write it in the comments, although he's struggling a little bit, but yes, I'm sure you must have gotten it. So how do we draw a straight line? I'll just figure out few points. If I process x as 0, y will be 3. So there will be a point 0, 3. I'll see 0, 3 somewhere here. If I put y as 0, x will be minus 3 by 2. So minus 3 by 2 could be somewhere here. So this point could be minus 3 by 2, 0. And if I join these 2 points, I get a straight line, and it is nothing but y is equals to 2x plus 3. Absolutely true. Yes, it's a linear polynomial. Good. I'm sure those who are watching it sincerely keep participating, keep interacting, keep commenting. That helps you in understanding the session better. That keeps your attention focused. That lets you concentrated. That keeps you involved. You don't lose your focus very easily. So keep participating, keep interacting, keep yourself involved. Keep answering, keep telling me whatever you are getting as your doubts. I'll definitely be really happy in resolving them. You cannot, but I will understand. As a teacher of maths, I will, don't worry. So here I'm trying to tell you that here this is a linear expression, which is technically a linear polynomial, and linear polynomial always gives you a straight line. Again, can you help me with two things? What will be the domain here? And what will be the range here? Again, how do you process the idea of domain and range? So to notice or check domain and range, I'll track the function along with the x-axis. So if I'm tracking the function along with the x-axis, I can track it from minus infinity to infinity without any interruption. It exists everywhere on the x-axis. So if it does exist everywhere on the x-axis, what about its domain? So its domain will be all the real numbers, that is from minus infinity to infinity, open interval. Sir, what about the range in that case? Will I not say if I want to track the function along with the y-axis, again I'm able to track the function along with the y-axis everywhere on the y-axis, that is from minus infinity to plus infinity, yes or no? Which means again, here I'll say that range is also R. Shall I tell you one very interesting fact over here? Shall I tell you one really important fact or observation here? Polynomials or polynomial functions, you can define or divide into two categories. Polynomial functions can be divided into two categories. One are even degree polynomials and other are odd degree polynomials. One thing for sure, you can always remember that if you ever encounter odd degree polynomials, their domain is going to be R and their range is also going to be R. Sir, what do you mean by that? Look at this scenario. The degree of this polynomial is 1. The degree of this polynomial is 1, which means the power of x is 1, which means here it was an odd degree polynomial. And for an odd degree polynomial, without any hesitation, you can say its domain and range both will be R. Mark my words, it will always happen. Which means, let's say if I'm giving you fx as, let's say, 5x to the power 7 minus 6x to the power 6 plus 4x cube minus 2x square plus, let's say, x plus 8. Let's say this is a polynomial. What is the degree over here? So the degree is 7, which is odd. So if the degree is 7, which is odd, it is an odd degree polynomial. Its domain and range both will be real numbers. Without any hesitation, you can always say so. Everybody got my point? Everybody understood my point? Or shall I repeat it? All the participants. But let's say if I talk about an even degree polynomial. So even degree polynomial, let's say if I'm talking about an even degree polynomial, like let's say 3x squared plus 2x plus 5. In that case, what is going to happen here is that if you are ever encountering an even degree polynomial, then domain for any polynomial, even or odd, whatever it is, will always be real, but range will not be real number for even degree polynomials. It is a quadratic. So when you draw a quadratic, it will be either an upward facing parabola or downward facing parabola, depending on the quadratic's highest degree terms coefficient, which is coefficient of x square. So if 3 is given over here, which is positive, it will be an upward facing parabola. If coefficient of x square is negative, it will be a downward facing parabola. And here in this case, wherever the x-axis and y-axis are, they will keep going up till infinity, but it will attain a certain minima. So its range will be some fixed value to infinity. Sir, what will be that some fixed value? I'll teach you to figure it out. Don't worry. But did you all get whatever I've explained so far? What am I trying to tell you here is, this is something which is, I think, not there in syllabus right now at this stage in 11th class. But still, from the JEE's perspective, if I could tell you this, remember this as a concept that for odd degree polynomials, domain and range both are real numbers. But for even degree polynomials, domain for any degree polynomial is real numbers, but range will be, for even degree polynomial, will not be a real set. That means the set of real numbers. It will be a subset of real numbers, a proper subset of real number set. Are you all able to understand this statement, this example? Exactly. That's good, Vijay. What about the other participants who are watching it sincerely? Did you all get it? Did you all understand it? Or shall I re-explain? Everybody got it? Everybody understood it? Shall I move ahead with this? Let's talk about few more polynomials. Let's say there is a polynomial given as x squared plus, let's say, 2x plus, let's say, 1. That's a polynomial given to you, right? Now, when you wish to draw this polynomial, you can draw its graph, you can draw anything related to it, but still, let's say if you don't know a lot of things about it, can you not write it as x squared plus 2x plus 1 as, for a while, y is equals to x squared plus 2 into x into 1 plus 1 square for a while? Can you treat it like this for a while? And if you could convert it into a perfect square, it will look like a square plus b square plus 2ab. So it looks like a plus b whole square. Yes or no? Everybody getting it? Now please pay attention, everyone. X plus 1 whole square I have. Use your brain and tell me what all inputs can you pass here? What all inputs can be processed here? Sir, I'll say if it is x plus 1, again it's a polynomial. I can try any value of x. Yes. So if I can try any value of x, I will say any inputs can be given, which means the graph will exist from minus infinity to infinity along with the x-axis. Everybody getting it? Everybody agreeing with me on this? Are you all processing this idea? Yes or no? But sir, what about the range? What about the range? Okay, let us use some basics of maths. Let's use some basics of maths. You tell me, sir, x plus 1 can be any real number. Because if x is any real number, x plus 1 can be any real number. Yes, Vijay, inputs are all the real numbers. So if x can be any real number, x plus 1 can also be any real number. But sir, it's a square. It's a square means a square of x plus 1. Don't you think it will be always non-negative as we have just discussed? When you square the real numbers, what you get is non-negative real numbers. When you square all the real numbers in the world, the squares are going to be either 0 or positive, which I can call non-negative real numbers. So what is going to happen over here is that you will see a curve, a parabola touching the x-axis at minus 1 comma 0, and it will go like this. Sir, how did you know that this is exactly the graph will be drawn? I'll definitely tell you, with the time, you will also be able to process it. Once you go or enter into 12th standard, you will learn a lot of things regarding functions. The same chapter, relations and functions, you will study again in 12th standard. There you'll learn a lot of things, transformation of graphs and a lot of things. So there I'll explain it, don't worry. But right now, if I ask you the range, will you say the real numbers? No, of course not. Of course, Vijay, when I ask you the range, sir, the graph exists along with the y-axis from 0 to infinity. We are noticing the graph exists in this case along with the y-axis from 0 to infinity. Which means in this case, if domain could be all the real numbers, range would be not all the real numbers, it would be 0 to infinity. Excellent, students. Keep it up. Keep it up. Really good. I hope everybody got it. Everybody understood it. So far, is there any confusion? Shall I move ahead from here? Now, sir, what do we mean by rational functions? Rational functions means if you are seeing, let's say, two polynomials, but in the form of px upon qx. What did I just say? Let's say if I'm given something as 2x plus 3 upon x minus 2. So this is a polynomial function? No, it is a rational function which has numerator and denominator as polynomials. That's a rational function. And for a rational function, what you all need to understand is that denominator can never be 0. So here I'll say x minus 2 cannot be 0, which means I'll say x cannot be 2. Can I really keep x as 2? You tell me. Sir, why can we not keep x as 2? You tell me. If I keep x as 2, I'll get 2 minus 2 in the denominator. And if the denominator approaches 0, the whole fraction will approach infinity. Getting it, everyone? Yes or no? So I hope you do realize that x is equal to 2 cannot be tried over here. If you want a better explanation of this rational function, let me explain this with a better example or a better scenario. Here we are. I'll explain it with, let's say, one very beautiful and interesting tool. Let's say Desmos I'm choosing. Give me a moment. I'll explain it very beautifully. So we have Desmos as a tool and I'm drawing the graph. My daughter, 3-year-old, she draws a lot. She uses all of these things. And whenever we ask her, what are you doing? She says, doing. She's not able to, speak these words. She is 3 years old. So whenever we ask her, what are you doing? She says, doing. So here we are. Let's say if I ask you to draw the curve y is equal to division of, in the numerator, I wrote y twice. I don't know why. Let me just remove this. And then, Give me a moment, everyone. Are we disabling it? Yes, I think it is disabled. And I think, what is going on? Give me a moment, everyone. It is off. So with this, reverse the contrast, but this is still not getting disabled. What's going on? Okay, anyways, I'll show it to you. Don't worry. So I am drawing a graph. Y is equal to. Y is equal to. Where is backspace? There is backspace. Why is it not? What is going on? Shall I refresh? Give me a moment, students. I'll refresh it so that it becomes more understandable. So this is the original version. Reverse the contrast. Now it will be more proper. So I'm giving you a function y is equal to. So this is the y is equal to numerator and denominator I'll have. So in a numerator, I'll give you, let's say, 2x plus 3. Bracket closes. In the denominator, let's say I give you in bracket I write x minus 2. Now look at the beauty here. Look at the beauty here. Are you noticing something amazing? Are you noticing something very beautiful over here? This is how the graph of this rational function looks like. And do you all realize when you look at the graph, this all you'll understand in 12th standard when you study calculus, which got developed by Newton and Leibniz. There they came up with a lot of very exciting and amazing things. They invented calculus where they came up with functions, limits, continuity, differentiability, derivatives, application of derivatives, integration, indefinite, definite. Then they came up with area under the curve, differential equations, everything they came up with. Amazing, amazing discoveries they made. Those results will be studying in 12th in calculus. But right now, all I can say is that this is how the graph will look like for you all 11th class students. So if I talk about the curve, a rational function, I hope you are clearly noticing that exactly at 2, the graph breaks. Exactly at 2, the graph breaks. Exactly at 2, the graph breaks. And before 2, it is decreasing. After 2 also it is decreasing. But at 2, there is no existence of the graph. The function does not exist at 2. That's a very good observation, Vijay. Everybody got my point. Everybody understood my point. Everybody noticed it. That was my point. Yes. And that's what I meant by this thing, that x cannot be 2. Did you all realize? Did you all understand this? Everybody, yes or no? So I come back to this discussion which we were learning and explaining here, that here if I ask you the domain, what will you say? So domain of this function will be, you can take all the real numbers in the world, but you cannot try 2 on the x-axis. So 2, if I could not try, is going to be the domain. But sir, in this case, how do we figure out the range? How do we work out the range? Can somebody in the comments tell me, in these kind of questions, how do we work out the range? Anybody? There is a very interesting approach here, which I'd like to tell you, although this is also what we teach in 12th, but still to 11th class students, I'd love to teach it. So concept of range can be brought. Let's say this is y. So if I cross multiply, it is xy minus 2y, which is 2x plus 3. Now, if I bring this 2x here, 2y there, I'll have xy minus 2x is equal to 2y plus 3. If I take x common, I'll have y minus 2 is equal to 2y plus 3. Then I'll push this y minus 2 to the other side. So what I'll have is x is equal to 2y plus 3 whole divided by y minus 2. What does it mean? What does it mean? It means I could explain x in terms of y. I could express x in terms of y. So previously, if y was our dependent variable and x was our independent variable, now x becomes the dependent and y becomes the independent. And it clearly tells you about the range, doesn't it? Absolutely, Vijay. That's brilliant. And I'm sure all the other students who are watching it sincerely must be able to crack that, sir, yes, we got the idea. Y cannot be 2. Why? Because y minus 2 is in the denominator, and there I'll say y cannot be 2. And what was y technically? Y was f of x, yes or no? So if y was originally f of x, I think my job is done. I'll say, sir, its range is also going to be all the real numbers except for 2. So do you really think that 2 cannot be taken? Yes, yes, yes. Why? Let me prove it. I am saying that y cannot be 2. If you believe that y can be 2, let me prove it wrong with this simple example. Let's say this is y. So y is 2. So if y is 2 means what? 2x plus 3 upon x minus 2 can be 2. Yes. So if x minus 2 is brought here, 2x minus 2 is equals to 2x plus 3. So 2x minus 2x is 0. So what you have proven is minus 2 is equal to 3. That's impossible, sir. That's mathematically incorrect. So this is incorrect. This is incorrect. Did you get my point? Did you all understand it? Everyone able to process this idea, yes or no? Everybody. Shall I move ahead from here? If you were able to process the idea of a rational function, yes or no? Now there comes one very interesting function which is called modulus function, and it is also called the absolute value function. Sir, what does it really mean? Let's talk about that. Pay attention, everyone. It always gives you the numerical value of a number. Sir, what does it mean? It is given by fx is equals to modulus of x, and mathematically it is defined as x if x is non-negative and minus x if x is negative. How many of you were aware of it? How many of you already knew it? Modulus function. Write in the comments. With this, what I'm trying to tell you here is a very interesting fact that here, first of all, let us understand how does modulus function behave. So modulus function here means, let's say if I ask you modulus of minus 3.2. So negative is the sign over here and 3.2 is the number here. So whenever you put a modulus sign over a number, then you get rid of the sign and you're finally left with the numerical part. So the numerical part over here is 3.2. Got my point? Let's say, for example, if I ask you magnitude of 5.7. So 5.7 has positive as its sign and 5.7 is the number here. So if you put magnitude modulus sign over a number, then it always gives you the absolute value. What is the absolute value? Absolute value, the numerical part, the number is 5.7. Everybody got it, or shall I re-explain this part? Did you all understand the functioning of absolute value function? Vijay, again, correct your language. Output is not positive. Output is non-negative. Output is non-negative. Yes or no? Thank you so much, Piyush, for your kind words. I hope you'll stay and understand everything till the end. Here we are. I'll explain this. What will be the magnitude of 0.2? It's 0.2. What is the magnitude of 0? That's 0. So the output is non-negative. Yes or no? Everybody got my point? Yes or no? So if I come back here and if I could try and define this, how will I say that if, let's say, I'm given minus 3.2's magnitude. So I'll check minus 3.2. Minus 3.2 as a number is negative or positive? Is negative or positive? So if it is negative, I'll remove its magnitude with a negative sign on this number. So magnitude, modulus function says, if the number inside the modulus sign is negative, you put a negative on it. So negative negative makes it positive, and that's how you get plus 3.2. Got my point? Similarly, if I look at 4.7, so just check it out. 4.7 is a number is greater than 0 or equal to 0, which means it is non-negative. So if it is non-negative, in that case, magnitude of 4.7 is clearly 4.7, and that means this is how you'll simply write it. Thank you so much, my dear friend, your tech guy real, for watching the Engage series. Thank you so much for your compliment. And I'm sure you must have learned a lot from there. Yes, I understand your concern to cover algebra and trigo part as well. That we are covering here. If you are really interested and keen about IIT JEE preparation, you can watch our one-shot series on PWJ English. There we are covering it totally in a great detail format, in a great detailed manner. All the chapters of 12th we have already started covering, and very soon we'll start classes for 11th as well. So whatever your concerns are regarding algebra and trigo, we'll cover those there. Don't worry. Even vectors and 3D will cover there. So don't worry. Everything will get covered. We are here to cover everything. So everybody understood the concept of absolute value function. And that's exactly what we are doing over here. If you're putting mod over something, so if the number inside mod is negative, you put a negative on it so that it becomes positive. And if it is already non-negative, you just take the number as it is outside. Yes or no? Everybody processed it. Everybody understood it. Definitely, Vijay, you will keep getting these classes throughout this week, which means we'll be definitely helping all the aspirants of physics, chemistry, maths, and biology, class 11th and 12th aspirants, alternate days. I mean, let's say if Monday, Wednesday, and Friday classes are for 11th, then on the Tuesday, Thursday, and Saturday, classes will be for 12th standard students. Timing will be approximately this in the evening only, but it will keep changing depending on our availability. So I wish you all the very best. We'll be covering a lot of things. You're Tech Guy Real. You stay there. You just keep, stay in touch with us with PWJ English channel, and we'll be covering everything detailed. Shall I get back to this? So if I try to draw this graph, can somebody help me with this graph? Anyone? Of course, in the comments, you won't be able to draw it, but still you can give me some hints. Sir, as long as x is positive or non-negative, as long as x is greater than or equal to 0, you are saying it is y is equals to x. But if x is taking negative values, negative values, you are saying it is y is equals to minus x. So piecewise definition it is taking. It is a piecewise function. For non-negative values, it is x. For negative values, it is minus x. So piecewise definition it is taking. I mean, for all the values which are between 0 to infinity, it is x. But for all the values which are between minus infinity to 0, it is minus x. Yes or no? Exactly. So with this, what I'll say here is that it is again having its existence from minus infinity to plus infinity, along with all the values on the x-axis without any disturbance, fluctuation, or discontinuity. You cannot, but still, you can give me some hints the way your Tech Guy Real is giving symmetrical about y-axis or V-shaped graph, kind of, so that I can see that you know a few things. You know a lot of things, by the way, students. I'm really glad to have you all. Good. Keep it up. So with this, what do you think of the domain, students? What do you think of the domain? Can you help me with the domain? I hope you all must agree that a domain in this case is going to be nothing but what? Minus infinity to infinity. That means all the real numbers. But can somebody now tell me the range? What do you think could be the range be? What do you think could the range be here in this case? Again, I'll apply the same logic. If I notice the graph, I'm clearly seeing this a graph is existing from 0 to plus infinity. I'm noticing the existence of the graph on the positive side of the y-axis. Yes, 0 is there, but all the positive values are also there. But there is no graph on the negative side of the y-axis. That gives you a complete idea of the range, yes or no? So with this, what I'll say is that range here is going to be all the numbers from 0 to infinity where 0 is included. So all the non-negative numbers. Brilliant. Keep it up. Really nice. Everybody got this? Everybody understood this? Now there is called a Signum function. One of the students in our online classes and our batches, paid batches, is calls it Signum function. So yes, it is Signum function. What is Signum? It is a very beautiful function. They define it as Signum. They write it as Signum of x. So they say Signum of x is given by mod x upon x as long as x is not 0. And they write it as 0 the moment x is 0. Sir, it's very confusing. Can you not keep it simple? Sir, is one shot PYQs enough for mains? Definitely, it depends on what kind of preparation you're doing. That depends Chan. If you are doing or watching one shots and covering the theory, and if considering you are a good student, a brilliant one, and one shots are enough for you to understand all the theory, then yes, one shots are sufficient. And if you are really sincerely doing all the PYQs, when you are doing PYQs for ITJ, I'll say, let's say mains PYQs you are solving from 2020 to 2026. And not only you are doing PYQs, you are classifying them as easy, moderate, and tough. Easy ones, let's say you're able to do, you don't look them again. But moderate ones, you're revising again. And tough ones, you're solving again in future. You're keeping them reserved for your revision. Then of course, you hold a good chance. If you're sincerely doing all the PYQs from 2020 to 2026, trust me. Exactly. So we define signum as this. But sir, this is still a very confusing definition. Can you keep it simple? Can you simplify it? Yes, I can. Why would I not? Here we have. Let's say x is not 0. So sir, when x is not 0, what can it be? It can be either positive or negative. So can I say when x is positive, mod x is x. Mod x is x. So it will be x upon x. Sir, when x is 0, it is 0. And when x is negative, that means x is not 0, mod x is minus x. We have just learned in the absolute value function, haven't we? So it will be minus x upon x. Now, can you help me with this better definition? Can we simplify it further? Sir, x upon x is clearly 1. So I could have written it as 1. 0 is clearly 0. So you could simply write it as 0. And minus x upon x, we need not tell you. You already know it is minus 1. It is clearly minus 1. So this is how you define signum function. Yes or no? By the way, Ekchan, if you are sincerely preparing for ITJEE, on our PWJEE English channel, we have already started conducting one-shots for 12th standard. And very soon we'll be starting one-shots for 11th class as well. Now, if I redefine it graphically as well, how will I do it? Can somebody tell me how will the graph look like? Through words, if you can try. What do you think? Sir, signum of x, if I try and draw its graph, what do you think, sir? Sir, for all the negative values of x, which means for all the values which are between minus infinity and 0, its graph stays constant, which is minus 1. But at 0, it is not minus 1, sir. At 0, it is 0. At 0, it is 0. And for all the values between 0 to infinity, it holds a value 1. It holds a value plus 1. Absolutely, Vijay. Absolutely. That's brilliant. That's good. Keep it up. Really nice. So I hope everybody got this complete idea about signum function here. Yes or no? All the participants. Did you all get it totally? Did you all understand it completely? Everybody got a crystal clear idea about this thing. Yes or no? So what I'm trying to ask you is one more very interesting fact here, which is, can you now help me with the domain and range of this function? Can somebody help me with the domain and range of this function? Sir, I think it's very easy now. You just look at the graph. The graph on the x-axis exists everywhere along with the x-axis. I think I can see its existence everywhere along with the x-axis. So the graph breaks here. Although it broke, it jumped from here to here and then here to here, but still it existed everywhere for negative values, for 0, for positive values, yes or no. So in that case, what will I say is that its domain is all the real numbers. Now, can you help me with the range? Good, Vijay, that's brilliant. Yes, Bhavyansh J, you can go. Definitely you can prepare and do your preparation sincerely. We'll be really there to help you, assist you at every single stage in whatever possible ways we can. But Ekchan and everyone, do you all realize this? Everyone. Yes, random rabbit. What do you think? What could be the range here? Can somebody help me with the range? Anyone? Be quick. I hope some of you must have already noticed that, sir, it is very evident, it is very clear that range is either minus 1, 0 or 1. These three values are there. It's like constant function for negative values, minus 1 for 0, 0 for positive values, it's 1. So there are exactly and only 3 terms in its range. Absolutely, you all are true. Perfect, brilliant, give it up. So range I'll be defining as only 3 terms, minus 1, 0 and 1. So set theory, curly brackets, yes or no? Absolutely, absolutely, Ekchan and everyone. That's good. By the way, what are your real names? Can you not keep your real names? It's really tough to take your names like Ekchan, Random Rabbit. So coming or going ahead from here, shall we talk about a few more functions? This is a very beautiful function. And here, let me give you the disclaimer. The disclaimer is, don't consider GIF, the greatest integer function, as a function which you will use to, take the significant digit or something like that, where you just, shorten it. No, it's not shortening of a number. I repeat, first of all, Bhavyans, yes, I will, but this is how I'll do it. This is how I'll do it, or this is where we'll be doing it. Greatest integer function is actually a very interesting function where students do get confused. So let me first of all clarify what is GIF. Let's say I'm asking you to find out GIF of 5.2. So this parenthesis sign is reserved for GIF. Okay, Sohadra, good to have you. Okay, Sohan. Good random rabbit. And Ekchan is our Rahul, very own Rahul. Okay, so this is how you should keep your names. Why would I call you Ekchan or random rabbit? Anyways, coming back here. 5.2. This parenthesis sign should be specified in the question that it represents GIF. For example, here, this represents modulus, right? So this bracket should be specified in the question that it represents GIF. GIF is not that GIF which you forward in messages. This GIF is GIF, greatest integer function. Absolutely, Vijay. So how will you define it? I'll define it that number scale, on number scale you point 5.2. And you tell me all the integers which are either less than or equal to this number. So of course, our 5.2 is not an integer, but less than 5.2, I see a lot of integers like 3, 4, 5, and so on. And among them, the greatest is 5. So greatest integer of 5.2 is 5. Did you get it? Everybody understood it? Or shall I re-explain this? All the participants. Have you all gotten it? Yes or no? With this logic, what if I ask you GIF of 3.7? Don't tell me 4, please. People have been telling me 4. I don't know why. Here, 3.7. Locate it on the number scale. 3.7 is of course not an integer. So look for the integers which are less than or equal to it. Among them, which is the greatest? Sir, 3. So greatest integer of 3.7 is 3. I think it's very easy, understandable and doable. Yes or no? With this, what if I ask you GIF of, let's say, minus 1.2? So again, you locate it on the number scale, minus 1.2. Minus 1.2, of course, is not an integer. So less than it, of course, minus 1 will be here, minus 2, minus 3. So less than it, all the integers are minus 4, minus 3, minus 2. And among them, which is the greatest? Sir, minus 2. So GIF of minus 1.2 is not minus 1. People confuse it with minus 1. It is actually minus 2. Yes or no? Good. Sick of. What is sick of now? Absolutely 3. Indeed, that's true. Good. Keep it up. Now, with this, if I move ahead with few more conclusions, can somebody help me with the GIF of, let's say, 7? What will be the GIF of 7? So again, can you help me in locating 7? All the integers which are less than equal to 7 are 5, 6, 7. Among them, which is the greatest? Sir, 7. So GIF of 7 will be 7. Absolutely. Good. Keep it up, students. Good students. That's brilliant. Really nice. Similarly, can you help me with the GIF of, let's say, minus 10 if I ask you? What will be the GIF of minus 10? Again, I'll ask you to locate minus 10 on the number scale. Greater than it will be minus 9, minus 8, and so on. But less than equal to it will be minus 10, minus 11, and so on. Among them, which is the greatest? Sir, minus 10. So GIF of minus 10 is minus 10. Everyone comfortably able to understand it? Yes or no? Give me a quick response. Yes, Arthe Indian. That's brilliant. It's minus 7. Absolutely correct. It's plus 7 and it is minus 10. Absolutely correct. Hitaishini. Why are you guys putting your names like this? What's your name, by the way? Arthe Indian. Why is your generation keeping names like this? And again, if I see it, I'll again call it sick of. Why will I call it Hitanshini? Anyways, shall I continue further from here? Did you all understand the concept of GIF? Now, if you have understood the concept of GIF, Mr. Sahityan, how will you draw the graph of it? How will you draw the graph of it? Can you help me with the graph of GIF of a function? So let's say this is y-axis. This here is, let's say, x-axis. And what I do here is, let me see few lines which are parallel to the x-axis like this. Let's say it is passing through 1, then it is passing through 2, then it is passing through, let's say, 3, then it is passing through, let's say, 4, here it is passing through, let's say, minus 1, it is passing through, let's say, minus 2, it is passing through, let's say, minus 3, and so on. I'm just keeping it restricted here. Also, along with this, I'm drawing some lines parallel to the y-axis as well. So let's say this is a line passing through 1, 0, 2, 0, 3, 0, 4, 0, like this, and so on. Similarly, on the negative side of x-axis as well. So let's say this is a line parallel to it, a line passing through minus 1, 0, a line passing through minus 2, 0, a line passing through minus 3, 0. Sir, why are you really doing it? Why are you complicating it? Have patience. Have patience. I'll do it. Thank you so much, all the people from north, south, middle, center, east, everyone. We really appreciate your efforts. Thank you so much. Good, keep it up. So here we have, this is 0, this is 1 comma 0, this is 2 comma 0, 3 comma 0, 4 comma 0. This is -1, this is -2, -3 comma 0. Similarly, this is 0 comma 1, 0 comma 2, 0 comma 3, 0 comma 4. This is 0 comma -1, 0 comma -2, 0 comma -3, and so on. Now, when I wish to plot the GIF, how will I do it? Pay attention, everyone. How will I plot GIF? Everyone. For all the values between 0 and 1, 0, 0.1, 0.2, 0.3, 0.5, 0.9999, what will be the GIF? So 0. So how will the graph look like? The graph will look like this. It will go like this. But at 1, the GIF of 1, 1.1, 1.2, 1.3 till 1.9 will be 1. So the graph will look like this. At 2, the graph will be what? 2. So 2, 2.1, 2.3 and so on until 2.9, the GIF will be 2. But at 3, it will be 3. Yes or no? So are you seeing something really interesting? I hope you got the pattern. I hope you understood the pattern now. You can clearly see that all the values -0.1, -0.2, -0.3 until -0.999 until -1, they'll have their GIF as -1. So I think we indeed have cracked the pattern now. What does it look like? What does it look like? The green part. Definitely Raj Sarvan. Good, 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 good. Keep it up. That's good. Stair. Absolutely, absolutely, absolutely. So I hope everybody is clearly noticing it is a stair function as well. So it is called stair function as well. The graph looks like step function. So they call it step function as well, stair function as well. Absolutely, Akshan. That's good. So it is clearly a stair function, a step function also they call it. Absolutely, indeed, that's true. So everybody got GIF? Yes or no? Now, good Vijay, good, 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 good. Kriya Kankalia. I'm really sorry if I could not pronounce your name correctly. But here in GIF, what if I ask you, how do you define it? So fx is given by GIF of x. This is the sign which is reserved for it, but it should be mentioned in the question specifically. What if I ask you the domain here? Can you help me with the domain? Domain is going to be what? Sir, I think I can try all the numbers. I could try all the numbers on the x-axis. Yes or no? I could try all the numbers on the x-axis, which means domain will be all the real numbers. But what about the range? Can you help me with the range in the comments? I'll be really appreciating it. Quickly tell me the range of this function. Somebody, please. Very quick. Tell me, what do you think is the range? Good, good, good. It's respect short. What your names are. Come on. Good, 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 good. Faizan. Vijay, now I'm asking you the range. Anyone? Quickly, what do you think could be the range? Sir, if you notice, along with the y-axis, I am getting all the integral values only. The output is all the integral values only. I am not getting any value apart from integers. Yes or no? Absolutely, Vijay. That's good. That's good. That's brilliant. I hope all the other students must have also gotten that, sir, when you talk about range, it is the set of integers. And set of integers is given by either z or I. Everybody got it? Good, 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 good. Excellent, Sikov. Respect shorts. Anandji, yes, 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 yes. Absolutely, Ekchan, that's good. Ekchan, no, real number is not the range. Range is the set of integers. Good, good, good. Raji Sarvan, that's good. Brilliant. Keep it up. Good. Excellent, Sikov. Shall I move ahead from here, all the participants? Shall we talk about few more functions? Now, algebra of real functions, if I wish to discuss or talk about. Here we have something really interesting. Let's say two functions are being added. Let's say there are two functions. So let's say one function is x, other function is GIF of x. Let's say f of x is x, gx is GIF of x. So if I want to add those two functions, I definitely can. This is how you add two functions. If I ask you difference, let's say fx minus gx, let's say if I ask you, so that will be the difference. If I want to multiply, I can multiply them like this. If I want to divide, I can divide them like this. This is how you can do it. But sir, no, Anji, greatest integer function never gives you, does not always gives you the positive values. I think we have already discussed it, haven't we? If you have been watching it, I think it produced negative values. It did produce negative values, didn't it? I hope you did notice it. It can produce all the integers, whether negative or positive. So when I talk about functions, you can add them, you can subtract them, you can divide them, you can multiply them. Yes, Sahitya. So with this, sir, why are we really doing it? Let me explain that part. Let's say there is a function. Let's say there is a function which is x squared plus 2x plus 3. And there is another function which is 3x minus 2. And with these two polynomial functions, one is quadratic, other is linear, I got a rational function. Usually in the evening, but the time we are not keeping fixed, but in the evening, you get these free classes at absolutely no cost, at absolutely free of cost. We are conducting these classes for all the 11th and 12th class students. With these one shots, we'll be covering all the chapters: physics, chemistry, maths, biology. I mean, geology, botany, all what you have in biology, I'm not aware of it, but all those chapters, even English, will get covered as a subject at absolutely free of cost. Not just that, the free course, the link which you are seeing in the comments, pinned comment, or even in the description, this will take you to our free course on pw.live. There you'll get these handwritten notes, PDFs at no cost, with 24/7 doubt solution feature as well, at absolutely no cost. All of this entire series for this year is free for all of you. All the subjects, I mean, for PCMB students we are doing here. So if I get back to this discussion, I am saying that if numerator upon denominator I did, which means a function got divided by another function, a quadratic in the numerator, another linear equation or expression in the denominator, then what do we have here? Sir, we have a function upon function. So a function when added to a function when multiplied to a function, when a function subtracted from another function, or a function when divided by another function. That's the algebra of functions. But sir, why are we really doing it? So when algebra, yes, PDF is available on our pw.live channel. If you enroll for this course, which is free of cost, you'll get the PDF, you'll get the doubt support mechanism, 24/7 doubt support system. What does it mean? I fortunately recorded a short today on this feature. Let's say you're studying at 2 o'clock at night, and all of a sudden a doubt strikes while studying or preparing. How will you clarify this doubt? With our 24/7 doubt support mechanism, you can ask your doubt anytime, and you'll get it resolved instantly. That feature we are making available for you at no cost. You can enroll for free of cost in this batch by clicking on the pinned comment given in the comment section, or the link to our free course is given in the description as well. You can check it out. Coming back to this discussion, I repeat, let's say if I'm ever given two functions, let's say there is first function f, there is another function g. So I'm given f plus g, or f minus g, or f into g, or f divided by g. So this is how algebra or algebraic operations you do on functions. Now I am saying, let's say, what will be the domain of f plus g, or f minus g, or f into g, or f upon g? Can you tell me in the comments? Can somebody quickly tell me in the comments, what do you think? When two functions are added, subtracted, multiplied, or divided, what is the domain of these functions now? Let's say domain of f is df, domain of g is dg. So if you simply take the intersection, this will be the domain of f plus g. Not just that, the same domain will be of f minus g, the same domain will be of f into g, and the same domain will be of f by g, with one more thing, that I will avoid taking all the values of x where dg is becoming 0. I'll avoid those values as well of x where the function g is becoming 0. So I repeat, the values of x for which g is becoming 0 should also be avoided. All of those values of x will not be taken. Intersection, absolutely, Vijay. Very good observation. Definitely. Everybody got my point? Any confusions or queries or concerns so far? Shall I move ahead from here? Everybody, yes or no? So with this, we'll continue or start our discussion with the questions. So theory part is done. Part 1 of this session is completed. Now I'll begin with part 2. But let me have a 10 to 15 minutes break, and then we'll resume with the questions. You also take a break, hydrate yourself, stretch out, walk a little around. Don't stay seated for so long. And then we'll resume at 10 o'clock after 15 minutes. Is that okay? So another break, and then we'll continue with these questions. Everybody okay with that? So we'll be meeting very soon. after this break, and we'll be doing a lot of questions. Are you all ready? So there is a small break and then we'll resume. So take a break, have your dinner if you did not have your dinner, stretch, eat, hydrate, and walk, and then we'll come back. Yes or no? So I'm starting a timer as well so that it works as a timer here right below this break. It's a 15 minutes break and then we'll resume. So 1, 2, 3, 4, 5. Okay, shall we? Great. Let's meet after 15 minutes. So come back everyone, if you all can hear my voice, if you all can see me, come back everyone. If the system is still open in front of you, if the phone is still open, you all can hear me. The break is over. You must have hydrated yourself. You must have walked or stretched. You must have had your dinner, I think, in that break, and it was sufficient for you to recharge yourself and come back everyone. Yes, focus on your goals. What are you guys talking about? Let me also read some comments so that I can get some little bit idea what's going on in the comments. Sir, okay, this is definitely not for JEE Mains or Advanced. It is the basic, the core, the starting from scratch we are doing here. So NCERT board level discussion we are having here. Basics of these chapters we are covering here. Of course, for JEE Mains and Advanced, you don't prepare through one shots. You go through the basics and the core theory through one shots. If you want to revise a chapter, you go through one shots for JEE Mains and Advanced. But Prash, if you're really inquisitive or curious about IDJ Mains and Advanced, we have our own PWJ English channel. There also, we have started our series for you all. Yes, there through one shots, we are trying to cover theory. But of course, we also humbly accept this fact that to prepare for JEE Mains and Advanced, you, yourself, the students, the aspirants, need you to practice. You cannot learn swimming by seeing me swimming. You cannot learn riding a bike by seeing me riding a bike. You cannot learn a skill by seeing me performing that skill. You can learn that skill by actually performing that skill or art by yourself. The same applies to problem solving. So when you do problem solving, when you solve a lot of questions, there you develop the knack for problem solving. Got my point? I hope I have answered your query, Prash. I think I'm pronouncing your name correctly. Shall we resume, students? Are you all there? Great. So coming back to the discussion, first part of the entire theory of class 11 chapter relations and functions is over. Now we are resuming with the exercise part, the discussion of the questions part, the second part, the practice part. I hope you do remember this is the series which we are continuing for not only 11th class students but 12th class CBSE NCERT board students as well. So if you wish to prepare for boards in English, here we are in full-fledged English for you. And yes, that's good, Vijay. I mean, the moment I'm explaining this, he has already started coming up with the answers. Excellent, Vijay. That's the spirit, commitment, dedication, consistency we hope and expect. Cry Spy is also answering it. That's brilliant. Good. Keep it up. Keep it up, students. Along with this, I hope you do remember, students, that this series is for physics, chemistry, maths, and biology students, and we'll be bringing all these classes: physics, chemistry, maths, biology means botany, zoology, all what are things are there in English as well. Yes, all of these things will bring for you on alternate days 11th, and on the other alternate days math 12th classes will be there. Timing will be evening, so this is an absolutely free batch where with the help of one shots we are covering everything. So I hope you do remember, if you want to enroll in this free batch to get access to all these PDFs at absolutely free of cost and want to get your doubts resolved by 24/7 at any time instantly, you can click on the link given in the description or the pinned link given in the comments. Shall we resume, everyone? Are you all there? With this, if I get back to this, I am told set A is given by 1, 2, 3, 4, set B is given by 5, 7, 9. And then we needed to determine A cross B cross A cross B is B cross A, and A cross B and B cross A. First of all, can somebody quickly tell me A cross B? Some of you have already written it. That's brilliant. Keep it up, students. Keep interacting, keep participating, keep commenting. That's what keeps you involved. That keeps you focused. So keep doing good productive discussion. Which days are maths? It's not decided, but mostly on, I think, what day is today? Wednesday, I think. So Wednesday and Thursday, most probably. I'm not sure, but yes. So coming back to this discussion, A cross B, I hope you already know it, how to find it out, yes or no? A cross B, if I wish to write, how will you write A cross B? So A cross B is going to be 1 with 5, yes or no, first ordered pair. Then 1 with 7, yes or no, second ordered pair. Then 1 with 9. I hope you got the pattern. Now, second, third ordered pair we have written. Then 2 with 5, 7 and 9, yes or no? So 2 comma 5. 2 comma 7 and then 2 comma 9. Everybody getting it? Then 3 with same 5, 7 and 9. So I'll have 3 comma 5, 3 comma 7 and 3 comma 9. Everybody getting it? Yes or no? Then I'll have 4, 5, 4, 7, 4, 9. Yes or no? 4 comma 5, 4 comma 7 and 4 comma 9. Everybody got it comfortably? So that's your set. A cross B, the Cartesian product of A and B. And if that question is answered by some of you or most of you, I think this question I can give you as a homework question. But sir, how are you going to receive this homework question after the session? I hope you know the answer. If you enroll in this free batch, the link is given in the description in the pinned comment, you will get the access to this PDF at no cost. This homework, this solution, the PDF, the complete one shot of relations and functions you can avail. Absolutely. B cross A and A cross B are equal? Definitely not. B cross A will be 5, 1, 5, 2, 5, 3, 5, 4, 7, 1, 7, 2, 7, 3, 7, 4, 9, 1, 9, 2, 9, 3, 9, 4. So I think I have answered this question as well, didn't I? Good, Vijay. Excellent, excellent, brilliant. Keep it up, keep it up. Beautiful. Some of you are asking, N A cross B or N B cross A, is it same? Definitely, because product is commutative, isn't it? So an A cross B is NA into NB. And what is NB cross A? That's NB into NA. So that's same, yes or no? And by the way, what is that going to be? What is that going to be? What is that going to be? I hope you do remember, number of elements in A are 4, number of elements in B are 3. So number of elements in Cartesian product of A and B or B and A will be 12. Beautiful. Good, Sarthak. Good, Cryspy. That's excellent, students. Keep it up. Keep it up. That's really good. Keep it up. I really appreciate your efforts, the sincerity which you are putting here. Good. Keep it up. Really, really, really appreciate it. Keep it up. Excellent. I hope everybody has gotten all these 4 answers right. Everybody? Shall I move? Good, Ekchan. That's brilliant. Good, Sarthak. Keep it up. Now, shall we discuss the next question? Here we have the next question. We need to find out that if this ordered pair is equal to this ordered pair, then crack X and Y. So first question I'll do, second question you do, right? Everybody. Maresha, if you're Maresha, sets chapter you did not understand, then you go and watch our one shot. We have released a one shot on sets. Go and watch it. You will understand it totally. So there, if this ordered pair is same, that means this 4x plus 3 is equal to this 3x plus 5. Yes or no, everybody? And this y will be equal to minus 2. Everybody getting it? So with this, if I take this 3x there, 4x minus 3x is x. 5 minus 3 is 2. So x is 2 and y is minus 2. I think you got it. How many of you were able to crack it? Everybody write in the comments. How many of you cracked it? X and y as 2 and minus 2. And with this, I am sure you would be able to do the second question as well. Yes or no? All the participants. Yes or no? What do you think could be the answer to the second question, by the way? Can you quickly tell me the answer in the comments? Very quickly. Answer to the second question as well. Great. That's good, Vijay. That's good, Harish. That's good, Ekchan. That's brilliant. Keep it up. Keep it up. Really nice. With this, what am I told? X minus y is 6 and x plus y is 10. What do you think could be the answer over here, students? Sir, if you add both of the equations, you get 2x, which is 16. So x will be 8. If you subtract, if from this equation, if you subtract this, x and x are cancelled, 2y is 16. I hope you are getting it comfortably. Sorry, subtracting. So 2y is 4. So y will be 2. Yes or no? Yes or no? Yes or no? Everybody got it? 8 comma 2. Excellent, Vijay. What about other participants? Ekchan, that's brilliant. Good, 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 good. Excellent. That's really nice. Shall I move towards the next question in that case, if you were able to do it? Brilliant, brilliant. Keep it up, keep it up. Really nice. Shall we do the next question in that case? Can you help me in answering this question, students? What does it say? It says set A is given by 2, 4, 6, 9. Set B is given by 4, 6, 18, 27, and 54. Small a belongs to set A, small b belongs to set B. Then find the set of ordered pairs such that A is a factor of B and A is less than B. Can you define a relation now? That's a relation actually. So how do we define this relation? Sir, the relation, if I wish to write this relation, which I need to write where ordered pair I'll be taking, small a I'll be taking from here, small b I'll be taking from here, such that a is a factor of b. So let me take a as 2. Let me take a as 2. Thank you so much, Vikas. Thank you. Bye. So if I take a as 2, just give me a moment. By the time I'm having my tea, you tell me what do you think could be the answer? Ordered pair, everyone. Are you seeing the question in front of you? If you all have understood the concept, you must be able to solve it, everybody. So if I take A as 2, A is less than B. So B can be 4, 6, 18, 27, 24. No. B should be divisible by A because A is a factor of B. So B could be 4. Yes. B could be 6. Yes. B could be 18. Yes. Can I take B as 27? No, because 27 is not divisible by 2. So can I take B as 54? Yes. So first of all, these ordered pairs I'll take. Now, I'll take A as 4. I'll take A as 4. So 4 comma 4, no, because 4 is less than 4, no. 4 comma 6, no, because 6 is not divisible by 4. 4 comma 18, no. 4 comma 27, no. 4 comma 54, is 54 divisible by 4? No. Yes or no? So I'll not see anything with 4. Yes or no, all the participants. Now let's check it with 6. 6 comma 4, 6 comma 6, no, because 6 is less than 6, false. 6 comma 18, yes, because 18 is clearly divisible by 6. 6 comma 27, sir, I don't think there is 27 in the table of 6, but 6 comma 54, indeed, because 6 into 9 is 54. Absolutely, Harish. Good, Vijay. Keep it up. That's really nice. Good, 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 good. Excellent, excellent. By the way, what about 9 now? What about 9 students? 9 comma 4, 6 doesn't make any sense. 9 comma 18, indeed, indeed. Yes or no? 9 comma 27, yes. And 9 comma 54, definitely, because 9 is dividing 54 very clearly. I hope I'm not teaching too fast. You're able to process it. Yes, Mr. or Miss Shahbaz, I used to. Now we are here helping in preparing for your boards and your ITJ. For ITJ, you can watch us on PWJ English, and for your boards, we are here to assist you. Excellent, excellent. Good, Sarthak. But where is your answer? You didn't write your answer. Everybody got it? Everybody understood it? Shall I move towards the next question if you are processing all of these things in a crystal clear manner? Shall I bring the next question right there in front of you? It says, find the domain and range of the relation R, which is given by this definition. Excellent. Okay, let's understand this relation first of all. This relation says that here, it follows or has an ordered pair x comma y, where y is x plus 6 by x, where x and y both are natural numbers and x is less than 6. Okay, so if x is less than 6, let me define this set in terms of roster form. Very big answer. Absolutely not, Ekchan, but I think you were able to crack it. Yes or no? Yes or no? So if I define, this is set builder form, yes or no? So if I write all the ordered pairs manually, can I take x as 1 because x is a natural number? So if x is 1, 1 plus 6 upon 1. 1 plus 6 upon 1, that's 7. So 1 comma 7. Can I take x as 2? Let me take x as 2. So Sarthak, if there is a lag in your video, you can definitely refresh the screen. I think that will resolve your concern, because not everybody is complaining about the lag. If you are only the person who is complaining about lag, I think you need to refresh it. Or even if you are not getting it resolved, close the window and reopen it. But don't lose your focus. Don't go anywhere else if you are sincerely willing to prepare or study. So when I put a 2 here, 2 comma 2 plus 6 by 2. 6 by 2 is 3. 2 plus 3 is clearly 5. Yes or no? Now what about 3 students? If I try 3, 3 plus 6 by 3. 6 by 3 is 2. So 3 plus 2 is clearly 5. Everybody getting it without getting confused? Now with this, can I try x as 4? Let me. 4 plus 6 by 4. Sir, 4 plus 6 by 4 will be a rational or a fraction which is not an integer, and y has to be a natural number. So 4 I cannot try. I think 5 also we cannot try, because 6 upon 5 will again be a fraction which will not give me an integer. So 5 also I cannot try, and 6 I definitely cannot try because x is less than 6. So these are the three values or ordered pairs I get in this relation. Now, when somebody asks you about the domain, what do you think, students, will be the answer here? Domain. 1, 2, 3. Yes or no? How many of you were able to crack it? How many of you were able to crack it? Can somebody help me with the range here? Can somebody help me with the range? 7, 5, and 5. Yes or no? Everybody, 7, 5, and 5. Everybody got it. Everybody understood it. That's good. Vijay, are you making any mistake? No, it's 1 comma 7, Vijay. Why will it be 1 comma 6? Check it again. What are you doing? Are you writing the inverse? Are you writing the inverse of it? Good Ekchan, good Harish. That's good, Sarthak. That's brilliant. Keep it up, keep it up, keep it up. That's really good. Keep it up, students. You're going great. Excellent. Amazing. Now, can you help me with this question? Can you help me with this question? What are we told here? Is the following relation a function? Okay, so now function has come into picture. Can you help me in defining a function? Function definition, have we not discussed it? Function, what does it mean? What does it mean? Function, quickly, students. A relation, a special case of a relation is called a function if all the elements in the domain, have a unique image in the codomain. Remember that? So if I bring that discussion over here, let me do the mapping thing. So I think mapping thing will do a lot of justice here. For the relation 1, we'll do relation 2 as well, but let me do it for relation 1 first. So for relation 1, if I do it, this first question we are solving. Give me a moment. I'm really sorry for this. First question we are solving here. Relation 1. Let me do the mapping thing. So mapping says 2 is mapped with 3. Then 1 by 2 is mapped with 0. 2 is mapped with 7, and minus 4 is mapped with 6. And I hope some of you must have seen the problem. I hope you are seeing that so 2 is having an image 3 as well as an image 7. So 2 is having more than 2 images, more than 1 images. And if it does not have a unique image, what's the problem here? What's the problem? Sir, this is merely a relation, but this is clearly not a function, because here 2 does not have a unique image. Everybody got it? I'm sure some of you must have cracked it by the time I'm stating the answer. Yes or no? Yes or no? Everybody getting it? Yes or no? With this second one, can you help me with the second one now? What do you think could be the answer? Is it a function or merely a relation? Everybody. Second one, is it a function or merely a relation? Quickly, everyone. Now, when we talk about this thing, x and mod x, where x is a real number. So the pairing is done like this, that there is x and there is mod x. So let's say in domain, I have x. In range, I have mod x. So let's say x is 2. So what is mod of 2? 2. In domain, let's say I have minus 2. So what is mod of minus 2? That's 2. In domain, let's say I have 1. So what is mod of 1? Minus 1. What of mod of minus 1? That is also 1. So sir, this is the kind of mapping we are seeing. And if we are seeing this kind of a mapping, it is many 1. It is many 1. Yes or no? Yes or no? I think all the real numbers, modulus can be done. So technically, they are giving you something like mod x. And mod x, we have already learned, it is an absolute value function. It is modulus function, and it is indeed a function. We have studied it as a function, haven't we? We did discuss its graph as well when we were discussing the theory. This is clearly a function, isn't it? And if it is a function, it's a function. So I'll say this is a function where 1 is not. How many of you got it right? How many of you were crack it that, sir, it is going to be a function? How many of you were able to think like this? Shall I move ahead from here? Shall we do the next question? Everybody, are you all set? Are you all ready for the next question? Everybody, tell me in the comments, what do you think could be the answer to this question where you are asked to figure out the domain for which these two functions are equal? Sir, these two functions are said to be equal. These two functions are said to be equal, which means this and this will be equal. What is f of x? What is f of x? Sir, f of x is 2x square minus 1. What is g of x? It is 1 minus 3x. So if I take everything on one side, I get 2x square plus 3x minus 2 is equal to 0. I think splitting the middle term, yes or no? Yes or no? That's good, Vijay, Sarthak. Keep it up, keep it up. Really good, really nice. Very good. Keep it up. Really nice. With this, 2 into minus 2, that's minus 4. I want the sum to be plus 3. I think, sir, plus 4 minus 1 will do the job. Indeed, it will. Indeed, it will. So if I factorize it, if I split the middle term as 2x square plus 4x minus 2, I think my job is done. Now, if you do know the short trick, negative of this divided by this will be the first root. So x will be minus 2 here. Negative of this divided by this will be the second root. 1 by 2 will be my second value. So two values of x which we are receiving are 1 by 2 and minus 2, for which these two functions are identical. What does it mean? It means whether you find f of minus 2 or you find g of minus 2, it will be same. Whether you find f of 1 by 2 or g of 1 by 2, it will indeed be same. I hope you got it. I hope everybody was able to crack it. Yes or no? Shall we move towards the next question in that case? Everybody with me so far? Any concerns, queries, or confusions if you have, please ask. I'd love to clarify. That's good, Vijay. That's brilliant. Good, 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 Sarthak. Keep it up. Really nice. Now, shall I move towards the next question? What are we told? This question is asking you the domain. So two functions are given and their domain is asked. Shall we do both of them one by one? So domain of this question, first question, where fx is given by something upon something. Sir, in the numerator, we are noticing a polynomial. In the denominator also polynomial. So polynomials can take any values. Sir, polynomials can take any values, which means here in the numerator, x can take any real number. Here in the denominator, x can take any real number. But the problem is, whenever you see a rational function, something upon something, we avoid taking the denominator as 0. We avoid keeping the denominator as 0, don't we? So this denominator over here, which is x square plus 3x plus 2, I would not want to have it as 0. Yes or no? Getting it, everyone? Which means what? Splitting the middle term. So x square plus 2x plus x plus 2 should not be 0, which means negative of this is minus 2 divided by 1 is minus 2, and negative of this is minus 1 divided by 1 is minus 1. So I will not want to have minus 1 and minus 2 in my domain. Why? Because at x is equals to minus 1 and minus 2, the denominator will become 0. Yes or no? So what is going to be the answer for the first question? Sir, x can take any real value, but please don't put these two values, minus 2 and minus 1. Avoid keeping them. Everybody processed it comfortably. Did you all get it? Is there any confusion? Ask if you have any concerns or queries. For the second one, can you tell me the answer? You did discuss it with me when we were talking about algebra of functions, didn't we? Quickly tell me, what do you think could be the answer to the second question? All the participants, be quick. Be quick, be quick, everybody. Sir, GIF of x is defined for all the real x is defined for all the real x. And if two functions are added, multiplied, or subtracted, you simply take their intersection. What are you not able to understand, Mr. or Miss Kamle? I'll explain it, don't worry. Ask unhesitatingly if it is a genuine concern or a doubt. So if you take intersection of all the real numbers with the real numbers, that's clearly a real number. The domain of fx is going to be real number. How many of you were able to crack it? How many of you were able to understand it? Everybody, yes or no? I hope it was easy, simple, understandable, and doable. Shall I move towards the next question in that case? Good, Vijay. Keep it up. Really nice. Yes or no? I think I'm not able to process it. So let me just give me a moment, everyone. Here we are. Shall I? Everyone, let's look at the next question in this case. Here we are asked the range. Everyone, are you looking at range of the following functions given by? First question and second question. We'll do both so that you understand the concept of range as well. Everybody with me so far? Any doubts or concerns? Good, Vijay. That's brilliant. So I think good. Keep it up. So with this mod x minus 4 upon x minus 4. So if I divide it, this function, although you should be able to answer it with utmost clarity, but still if you're not able to answer it, let me do it in a more proper manner. So I'll say, sir, as long as x is greater than equal to 4. Sir, can we really keep x as 4? Because if I keep x as 4, 4 minus 4 will be 0. I'll get 0 in the denominator. So sir, x will be either greater than 4 or x will be less than 4. As long as x is greater than 4, x minus 4 is positive. Are you noticing it? You imagine any value greater than 4, like 5, 6, 7, 8. You put it here. This expression inside the mod will be positive. That means x minus 4 is positive. Is there any point of putting a mod over it? Absolutely not. So mod over x minus 4 for all the values of x which are greater than 4 will be simply positive, which means it will give me x minus 4 in the numerator. Denominator is also x minus 4. So I think you got my point, haven't you? Sir, what about x minus 4 for all the values of x less than 4? Sir, if x is less than 4, imagine any value less than 4, like 3, 2, minus 1, minus 2, anything like that, it will give me a negative value. So this x minus 4 becomes a negative value. So if there is a negative value inside the magnitude sign, how do we remove the modulus sign? Sir, by introducing a negative sign on it. So I'll put a negative sign over x minus 4 and I'll divide it by x minus 4 so that it becomes simple. And I think we are done with this question now. Aren't we, students? I hope everybody must have already noticed it, but I have tried simplifying it because we have done it in Signum function as well. So I hope it makes complete sense. Signum function, right? So x minus 4 by x minus 4 is clearly 1. X minus 4 by x minus 4 is clearly 1. So that's minus 1. So we are defining this function as either 1 or minus 1. That's it. That's it. Our job is done. Yes or no? So this function has its range as either minus 1 or 1. That's it. Only two values. Can you believe this? Sir, can it be 0? Never. You make it equal to 0, I'll give you 1 crore rupees. For any real value of x, if it is found to be 0, I'll give you 2 crore rupees, let's say. Shall I do the next question? Second question, shall we do, everyone? Shall we try the second question? 16 minus x square inside an under root. First of all, let's talk about its domain. Can you help me with the domain of this function? Can you help me with the domain of this function? So when you want to talk about the domain of something written inside an under root sign, square root sign, the square root of negative values is not defined. You can take square root of only non-negative values. So that expression inside that under root sign has to be non-negative, which means 16 minus x square has to be greater than or equal to 0. Which means x square has to be less than equal to 16. Now, this is what we teach in our classes, in our basics math session as well, that if you ever see x square to be less than a square, where a is a positive number, then you say x will be lying between minus a to a. This is a general result, which I'll hope and expect that you would remember. Did you all get it? So here, what I'll say is that if x square is less than 16, I'll say x square is less than equal to 4 square. So I can directly say that x will lie between minus 4 to 4. Sir, does it have anything to do with range? I don't know, but if you are asked the domain, absolutely, Vijay, what you'll say or come up with is minus 4 to 4. So if you are ever asked the domain, I think the input. So input I can take from minus 4 to 4. That's the domain. I think it was easy, doable, understandable, yes or no. Now, let's talk about the range. Everyone, please pay attention. It is going to be really interesting now. It is going to be really interesting now. Can somebody help me with the range in this case? Everyone, are you all focusing? So here, x square. Can you help me with x square? Sir, let's try and understand 16 minus x square between minus 4 and 4. So we know that 16 minus x square will always be positive or non-negative for all these values. But can 16 minus x square be anything? Let's try and figure it out. Okay, so let's begin with this data. X I know is from minus 4 to 4. I know about this x, so it is from minus 4 to 4. Okay, so what I know about x square is, if x is from minus 4 to 4, what I know about x square is, sir, it is always less than equal to 16. I repeat, if x is from minus 4 to 4, that's what I know. I know that x square is always less than equal to 16. Yes or no? Now, whatever real number or real value of x I take, x square, a perfect square it is. So perfect squares are always non-negative. This is what I know. This is what I can work out. This is I can predict based on my knowledge. And I'm sure you are also able to think like this. Yes or no, Vijay and everyone. I repeat, we know x square being a perfect square is always non-negative. And x square is clearly less than equal to 16 because that's what we have cracked from the domain part. Okay, so sir, this is not what we are interested in. We are interested in minus x square. Okay, so if in an equation, if in an inequality, if you multiply it by negative sign, what happens? Can you tell me in the comments? If an inequality or if an equation is multiplied by a negative sign, the sign changes. The sign of the inequation reverts. So it gets inverted. So here minus 0 is 0. This less than becomes greater than, and this less than also becomes greater than minus 16. Everybody got it? Yes or no? But sir, we are not interested in check it again with J and Sarthak. The answer is not 0 to 16. Check it again. Once again, you need to check it. You are making a mistake. You're committing a one silly error. I think you're not noticing something really important. Go through it one more time. We are still not done with this question. Pay attention, everyone. If I add 16 on all the three sides, can I? Yes, I can. So if I'm adding 16 on all the three sides, 0 plus 16. First of all, can I write? Okay, I'll keep it like this. 0 plus 16 is 16. This is greater than equal to 16 minus x square stays like that. And this is 16 minus 16. That's 0. Everybody getting it? Yes, Vijay. Yes, Vijay. Sarthak, check your answer once again. So can I first of all say in a better language, 16 minus x square, I know from my knowledge is from 0 to 16. Are you all able to think like this? But sir, it is technically 16 minus x squared. No, it is under root over 16 minus x squared. So in that case, what are you really going to do? I think you know the answer. I think you know what to do. I think you know clearly what is needed to be done next, don't you? Can somebody quickly tell me that if this is a number which lies between 0 to 16, they all are positive, they all are non-negative. So imagine this on the number scale. You have numbers from 0 to 16. You have numbers from 0 to 16. What happens when you take their square roots? What happens when you take their square roots? I hope I need not tell you. When you take their square roots, you will get 0 to square root of 16, which is 4. Yes or no? So this 16 minus x square inside and under root will lie between 0 to 4. How many of you got it? How many of you were able to crack it? Good, Sarthak and Vijay. Did you all realize it now? So don't be in a rush. Don't be in a hurry. This is exactly what happens when you are doing it at a little fast pace, when you're doing it at a little, more speed. Don't commit those kind of silly errors. I mean, you're doing it all correctly, but still you're not getting the whole marks. Still you're not getting the complete marks. That's a problem. Yes or no? So with this, shall we talk about this question now? They're asking us to redefine this function, which is given by this expression. Okay, how do we do it? Let's try and do it. So here, if I'm asked to redefine this, I'll say that fx needs to be redefined. So I'll give it a piecewise definition here. Hi Shubham Rathore, good to have you. Will you, or if you're genuinely interested in preparing for relations and functions for class 11 boards, we welcome you on board. So here we are. Fx is given by x minus 1, x plus 1. So critical points are going to be minus 1 and plus 1. And minus 2 and 2, they are already stopping me at. So I'll say, I'll keep it like this. X I'll keep from minus 2 to, let's say, minus 1. Then I'll keep x from minus 1 to 1. And then I'll keep x from 1 to 2. So these are the three parts or pieces I'll divide it into. Okay, so Shubham is not here for studying. Shubham is for something else. Keep it up, Shubham. But I'll just, would not want to see those comments. I'm just removing this comment. So here we are. Fx is defined as minus 2 to minus 1, something, I don't know that. Minus 1 to 1, something, I don't know that. 1 to 2, why did I really do it? Because, sir, x minus 1 becomes 0. X minus 1 becomes 0 at x is equals to 1. X plus 1 becomes 0 at x is equals to minus 1. So I'll break this whole function from minus 2 to minus 1, then minus 1 to 1, and then 1 to 2. So these three parts I'll break it into. Everybody who is watching it sincerely has understood it, that why did I divide the definition of this function into 3 parts? Everybody got it. Now, sir, how will you get rid of this modulus sign? It's very easy. Trust me, it's really, really easy. How? Let's talk about it. You take any value between -2 and -1. Let's say -1.5. I try -1.5 here. -1.5 minus 1, that's -2.5, which is negative. Modulus over negative, if you put, then it opens with the negative sign. Remember that concept of absolute value function we explored, yes or no? So if I wish to remove this modulus sign for this domain, it will contain a negative value, and negative value, if is there inside the mod, it opens with the negative sign. So x minus 1, if opens with the negative sign, will become 1 minus x, yes or no, everyone? Similarly, x plus 1, for any value of x which is between -2 to -1, try any value -1.5. -1.5 plus 1 is -0.5, which is again negative. So if there is a negative value inside this modulus sign, when modulus sign gets removed, it opens with a negative sign. So I'll put a negative sign, so it will be -1 minus x. Everybody comfortably got it, yes or no? Let's try any value between -1 and 1. The most beautiful thing is 0, yes or no? So if I push a 0 here, 0 minus 1 is negative -1. So when this expression x minus 1 is negative for all the values of x between -1 and 1, if I wish to get rid of the modulus sign, I'll open it with the negative sign. So x minus 1 will get opened with 1 minus x, yes or no? If I try 0 here in place of x, if I try 0 here, 1 plus 0 is 1, which is positive. For positive values, modulus sign simply gets removed and you'll be left with 1 plus x. I mean, it will simply get opened as it is. Let me try any value between 1 and 2. Let's say 1.5. So if I try 1.5 minus 1, which is 0.5, which is positive. So if this expression is positive, mod simply gets removed and you get the whole expression as it is. 1.5, if I try x as here, 1 plus 1.5, 2.5, which is again positive. So if I remove that modulus, I will remove it in the manner as it is, yes or no? So with this, 1.5 plus 1 is 2.5, and that's again what we have gotten as a positive value. So it will open as it is, x plus 1. Yes or no? Everybody getting it? Yes or no? Everybody understanding it? Any queries or confusions if you have, please ask. Yes or no? Shall I move ahead from here, all the participants? So with this, sir, is it? No. Let's simplify it further so that we can finally write it in a better format. So sir, 1 and 1 are cancelled. Minus x is minus 2x. So this is defined as minus 2x. Here, x and x are cancelled. So this will be simply 2. Here, 1 and 1 are cancelled. So it will be simply plus 2x. So this is how this f of x will actually be defined as. Good, Vijay. Good. Excellent. So here we are with the next question for the day. Are you all set? Are you all ready? Everyone. So this question, find the domain of this function. A very beautiful, a very interesting, and a very insightful question it is. If you are able to solve this, trust me, mark my words, you should prepare for IDJE as well. Yes. You have that ability, you have that knack, you have that aptitude in you. You have that ability to think. So, how do we prepare for IDJE in English? We have our own channel, PWJ English. There we are taking classes for you in English. Yes, and we have already started taking classes for all the students who are in 12th standard, and very soon for all the IDJE aspirants in 11th standard, we'll be conducting classes there as well. Here it is for NCERT board level classes. So if this function's domain is asked, I know one thing, sir, that this function has something in the denominator. So sir, first of all, whatever it is, I want to know that the denominator is never 0. Yes or no? Whenever there is a rational expression something upon something, we avoid keeping denominator as 0. Sir, there is one more problem. What problem? Sir, denominator has an expression inside that under root sign. And anything inside the under root sign has to be non-negative. Can it be 0? No, because if that expression inside the under root becomes 0, under root over 0 becomes 0, that means denominator becomes 0. So what is the final condition I'm supposed to put? Can you help me with that final condition which I'll be putting here? Anyone? I hope you do realize that here, the final condition I'll be putting here is GIF of x squared minus GIF of x minus 6 has to be positive. Sir, why not equal to 0? Equal to 0 means what? Denominator will become 0. Here you understand that this parenthesis sign represents GIF. This is not your GIF which you forwarded messages. This is greatest integer function. I hope you do understand it. With this, sir, how do we resolve it? How do we solve it? How do we work it out? I think splitting the middle term, isn't it the best practice here? So what I'll do here is minus 6, minus 1. I think minus 3 and plus 2 will do the job. So GIF of x square minus 3 times GIF of x plus 2 times GIF of x minus 6 greater than 0. If I take GIF of x common from here, I'll get GIF of x minus 3 from here. If I take 2 common from here, I'll get GIF of x minus 3 here. So what did I take common from here? I took GIF of x common from here and I took plus 2 common from here, and that has to be positive. Everybody got it? Now, can I take, okay, Sarthak, that's a good observation. We'll definitely verify it. Now, can I take some liberty to use the wavy curve method? Mind you, students, it's not wavy curve method. It is wavy curve method, which is a very interesting tool to solve inequalities. So here we have this thing over here. This is what I need to solve. For a while, if you are getting confused, GIF of x you can take as t. So let's say for a while to solve it, GIF of x I'm taking as t. Can I for a while? So this becomes t minus 3 times whole of t plus 2. Tell me in the comments how many of you already are comfortable with this wavy curve method. How many of you already know this wavy curve method? Quickly give me a thumbs up if you already are aware of this very amazing, insightful, interesting method which is called wavy curve. How many of you are already aware of it? Quickly tell me. So with this, sir, how do we solve this? The idea is really simple. You plot these numbers on the number scale, minus 2 and plus 3. Critical points are minus 2 and plus 3. So critical points are minus 2 and plus 3. You put plus, minus, plus like this. Sir, what do we want? We want it to be greater than 0. Greater than 0 means what? Greater than 0 means positive. Greater than 0 means positive. So I will say positive. I am finding this expression for all the values of t which are between minus infinity and minus 2, which means t will be less than minus 2. Or I am finding this expression to be positive for all the values of t which are between 3 and infinity. So I'll say t will be greater than 3. That's good, Sarthak. Good, Anand ji. That's good, good. Excellent. That's good. Brilliant. Keep it up. Really nice. Good, Vijay. I'm sure you must have used the same method. Perfect. Now, sir, do we really stop here? No, we don't. T is not what we are solving it for. We are solving it for GIF of x. So let's extend it further towards GIF of x, shouldn't we? So if I take 2 GIF of x, what do I get now? So technically, this question will be GIF of x should be less than minus 2, or means union. Remember that we had a discussion in the last session. Sets we discussed, and means intersection, or means union. Remember it? Exactly. And here t means GIF of x should be greater than 3. Now help me with this. I am looking for all the numbers in the world, in the real number world, where their GIF is less than minus 2. Where their GIF is less than minus 2. If you plot it on the number scale, imagine this is minus 2, this is minus 3, this is minus 1, and so on. Let's say if I take minus 1.5, what will be its GIF? Sir, minus 2. Can I take minus 2? No. Can I take minus 2? GIF of minus 2 will be minus 2. No, I cannot. But what if I take minus 2.1? What if I take minus 2.2? What if I take minus 2.9? Their GIF will be minus 3. Yes or no? So for this part, x is going to take all the values from minus infinity to minus 2, but minus 2 is open. How many of you were able to think like this? How many of you were able to crack this? Or shall I re-explain this part? What did I just say? I said that if GIF of a number is less than minus 2, then that number will be less than minus 2, but minus 2 is not included. Sir, why? Because you imagine it in your brain. Let's say if you take minus 2.1, minus 2.2, minus 2.3, minus 2.4, their GIF will be minus 3, minus 4, minus 5, and so on. So if I take all the numbers less than minus 2, their GIF will be less than minus 2. Yes or no? Yes or no? Everybody got it, or shall I re-explain this? Did you all get it? All the participants who are watching it sincerely, have you all understood it? Yes or no? With this, the next part, sir. The next part is or, means union. What does it say? Sir, there will be 2, 3, 4, and so on. So they want all the numbers whose GIF is greater than 3? So can I take 2.5? Of course not. GIF of 2.5 will be 2. 2 is greater than 3? No. Can I take 3.7? 3.7's GIF is 3. 3 is less than, greater than 3? No. Can I take 4? I think yes, because GIF of 4 is greater than 3. GIF of 4 is 4. Can I take 4.1, 4.2, 4.3, 5, 6, and so on? Yes, because 4.1, 4.2, their GIF will be 4, 5, GIF will be 5, 5.6, GIF will be 5. So any number greater than equal to 4 can be taken because its GIF will be 4 or greater. So I think I'll say all the numbers greater than 4 can be taken. Tell me honestly in the comments how many of you got this. Of course, this is also not a JEE Mains level question, but yes, this is exactly the kind of thinking or the approach or the thought process they expect and hope for from a JEE aspirant, from a sincere JEE aspirant. If you are really willing to prepare for IDJE, then we have a solution for you. We are bringing the live classes, these kind of one-shots for JEE aspirants as well on our PWJ English channel. Yes, shall I continue further? Shall I show some more questions to you? Everybody understood that part. Can you help me with this question, everyone? What do you think could be the domain here? This question, I'm asking you the domain. Everyone. Okay, Sarthak, that's good, Vijay. What about the other participants who are watching it sincerely? Are you all getting it? Did you all understand it? The whole solution? Or is it still confusing? Do write in the comments. I'll love to resolve that. With this part, again, I'm asking you a very simple question. Can you help me with the domain of this function? So if this function has again something in the denominator, that too inside the under root sign, what do we want? Sir, we want only one thing, that thing inside the under root sign has to be positive. Sir, why positive? Why not equal to 0? Because if it becomes equal to 0, denominator will be 0, and denominator we cannot afford to keep 0. Yes or no, everyone? This, when simplified further, tells us that mod x should be less than x. Sorry, mod x should be less than x. Now you tell me, do we really have this scenario? Do we really have this scenario? Let me give you some cases. You can do it algebraically as well, which you really don't have to. You use your brain and you can conclude it that this never happens. I repeat. Let me take some examples. Mod of minus 2.3. Is it less than minus 2.3? Sir, modulus always gives you something non-negative. And you're saying something non-negative is less than negative? Impossible. Let's say I take some other number, let's say 5.6. So mod of 5.6, will it be less than 5.6? Come on, sir. If it is already positive, its magnitude is positive, and that same number is less than itself, never happens. Getting my logic, everyone? If you don't get this, you can follow it or solve it algebraically as well. First case when x is non-negative. Second case when x is negative. So when x is non-negative, x opens as it is. But I think that's false. That doesn't happen. That never happens. Or second case when x is negative. So it is minus x less than x. Minus x goes to the other side. So 2x is greater than 0, which means x is greater than 0, which is a clear contradiction of it. I begin with this assumption that x is negative, but it tells me that x should be positive for that. I think it's clearly a contradiction of it. So I get nothing from here. I get nothing from here. An intersection of nothing with nothing, or union of nothing with nothing, is nothing. So answer is nothing. None of these. Option D should have been marked by most of you. Everybody got it. Shall I re-explain this? All the participants? No. Option 3, wrong. Option 3, false. Answer is option D. You try some values by yourself. With the options, you can try some values. For example, if you try minus 2, can you really put minus 2? Let me try minus 2. Minus 2 minus minus 2. Mod of minus 2. That's 2. So minus 2 minus minus 2. That's minus 4. Under root over minus 4. Not defined, sir. How can you take minus sign? Got my point? Yes, none of these. Good, Sarthak. Excellent. Keep it up. Shall I move ahead from here? Shall we try one more very beautiful, very interesting, and very insightful question? For this, I'll conduct a poll because it is an option-based question and we do have a feature. Are you aware of this feature, Pylons? This Pylons is such an amazing feature, students, that if you avail it, you can not only participate in these polls which we are conducting in live classes, but let's say if you are watching any random video on YouTube, then you can get quizzes, PDFs, mind maps, PYQs, a lot of things at free of cost with this Pylons feature. Will generate for you. We will generate it for you at absolutely no cost. Yes, this is an application which you can download from Google Play Store, or if you're watching it on laptop or in the browser, you can download it from Chrome Store. This application pilots. Trust me, it is a very exciting, amazing feature which you'll avail. That too at no cost. Any random video, let's say you're watching on YouTube and you want to generate a PDF on it, a short note on it, a mind map on it, a quiz on it, previous year's questions on that topic for any random video on YouTube, you can do it with this amazing app. Are you realizing the importance of it? So we have started a poll. Let's see how many of you get it right, and we'll see your names on the leaderboard. We would love to see your names on the leaderboard if you're genuinely participating in it. So let's see how many of you do get the right answer. So it says fx is given by this. Then they are asking you fx plus f of 1 by x. Okay. So what is f of x? Sir, f of x is x cube minus 1 by x cube. Then what is f of 1 by x? Sir, if x is substituted by 1 by x, it is 1 by x cube. And this is 1 by x cube, which is x cube. Everybody got it. And I think with this, I think I need not tell you, sir, x cube, 1 by x cube, 1 by x cube, everything gets cancelled and we get 0 as the answer. How many of you were able to crack it? How many of you were? 1? No, come on, Sarthak. The answer will be option C. Yes or no? Shall I re-explain that? Shall I re-explain that if you're getting the answer as 1? fx is x cube minus 1 by x cube. What will be f of 1 by x? It will be 1 by x cube minus x cube. So everything gets cancelled. Exactly, Vijay. Brilliant. Keep it up. That's really nice. So answer will be finally 0. Let's see how many of you got it. Option C will be the correct answer. So even if you're writing option C in the comments, we would pick it up for you. So let's see how many of you got it right. Option C, I'm stopping the poll and seeing the result. Vijay got it right. Vijay, brilliant. That's really great. That's really nice. I really appreciate your consistency, your efforts and your dedication today. You are there since the beginning of this session and you're participating so actively. You are responding every single thing. Good, keep it up. Really nice. And I'm glad that you're getting almost everything correctly. That's a really good thing which you're doing today. Let's move towards the next question. What does it say? It says A and B are any two sets such that number of elements in B are P, number of elements in A are Q, then the total number of functions. So shall I conduct a poll again? Integer type poll. So this poll has integer type options in it, which means whatever number you get as an answer, you type it here, you post it here. Whether if it is correct, your name will again get featured here. So try it, everyone. Let's see how many of you get it right. So what am I told here? I think there is a problem. You cannot get a numerical answer to it because P and Q are not numbers. So let's say P is 3 for a while and Q is 2 for a while. Then what do you think would be the answer here? So sir, here, total number of functions from A to B. So total number of functions, I think functions it is not relation, students, mind you, it is a function based question. So functions means what? Function means we'll be using some concepts of permutation and combinations here, which you may not be aware of. So let me do it, everyone. Please pay attention. If you are focusing and paying complete attention, you will understand it. So here it says A has 2 elements. Set A has 2 elements and set B has 3 elements. Set B has 3 elements. Yes or no? Everybody getting it? So I am asked that how many functions will exist. So if I approach A and ask it how many choices do you have? So it will say I can map with first element or second element or third element. So this first element will say I have 3 choices. And now let's say A is mapped with this. So how many choices this element has? So this element also has these 3 choices. Excellent, Vijay. That's a really good observation. David, yes, I think 8 could be the correct. Let's quickly verify this. So with this element also has 3 choices. So I think 3 into 3, unfortunately, it's, am I making any mistake? I don't think so. So the answer will be 3 square. It's not. I hope you got it. Shall I repeat it? Let me just check it. Am I making any mistake? Because B and A, number of functions from A to B. So A has 2 and B has 3. So yes, it will be 3 square. Total answer, correct answer will be 9. So David, I think you did opposite of it. You did 2 cube. But did you realize your mistake now? Are you getting it comfortably now? Did you understand what mistake did you commit? So with this, answer will be 3 square. So correct answer will be 9. Let's see how many of you got it right. Even if you're writing your correct answer 9 there in the chat box of this YouTube live, we would be taking it as an input. So let's see how many of you got that right. 9 would have been the correct answer. Let's see how many of you got it right. Nobody? Come on, unbelievable. Vijay, I was expecting this at least from you. Final question for the day, and then we'll be done. Then we'll be done. Then we'll be totally done with this session. Let's see how many of you are able to do this. How many of you are able to do it? So solve it, take your time, and write your final answer in the chat box. Final question for the day, and this will conclude this. Conclude what? Conclude relations and functions. The whole chapter from your class 11th boards, CBSE. Yes. Which means this entire chapter is done. You can take these notes with you, this entire PDF at absolutely no cost. How? By clicking on the link given in the description. It will redirect to you our free course for which you can enroll at absolutely no cost. You can not only avail this PDF, but you can get one more benefit, which is the feature 24/7 doubt support system. Whatever doubts, queries, or concerns you have regarding your academics can be resolved with that feature. Let's say you're studying at 3 o'clock at night. You want that doubt to be resolved instantly so that you don't stuck. You can continue your studies further. You can ask that doubt at that time and it will be resolved. Can you believe this? Yes. Coming back to the final question, what does it say? Domain of f plus g. I think you know it, don't you? Domain of f plus g is always domain of f intersection domain of g. We did discuss it. Yes or no? We did. So domain of f, if I ask you to find out, is 2, 5, 8, and 10. Yes or no? Yes or no? Domain of g, can you help me with the domain of g, students? So domain of g is 2, 7, 8, 10, and 11. Now, can somebody quickly help me with the intersection of domain of f and g? So domain of f and g, what is common? I think 2. So first element 2. 7, 5, no. Next thing is 8. And next thing is 10. Yes or no? Everybody got it? 2, 8, 10. That's brilliant, Vijay. That's good, Sarthak. Amazing. Excellent. Very good. Keep it up. Really nice. So I'm sure everybody understood this session. Everybody got it. Everybody comfortably got it. So what is the summary of this session? Solve previous year's questions of relations and functions by yourself now. What is your homework? The same homework. But what is my point here? Yes, you can rate our lectures. You can thank our lectures by rating our classes. I don't know whether this is available or not, but it is indeed available on our application. If you are enrolling it for free, you can rate our sessions and you can definitely get the benefit of this feature as well, so that you can rate our classes. Thank you so much, everyone. It was really nice interacting with you all. It was really nice talking with you all, communicating with you all, with all the sincerest students. I hope you got my point, everyone. Relations and functions we have done in this one shot for class 11th. If you want this entire PDF, you can click on the link given in the description, enroll for the course, and you can have the PDF at no cost. Doubts also will resolve. Functions for class 12th will do tomorrow. Functions for class 11th, we are done. So if you want to stretch it a little further, you want more inputs on relations and functions, come back tomorrow. For 12th class, relations and functions will be doing tomorrow. But for class 11th, yes, it's over. Shall we meet tomorrow? Thank you so much, everyone. You all were really nice. It was really nice interacting with you all. You were amazing audience. Keep it up, students. Let's keep meeting like this. Thank you so much. I hope you know that this series is for all the physics, chemistry, maths, and biology students. We are bringing it for 11th and 12th students at absolutely no cost. Let's meet in the next class. Thank you so much. Take a good care of yourself. Good night, everyone. Good night.